Hello there, and welcome to Just About Earth, the little space where curiosity gets comfortable and the big questions of the universe arrive without any rush at all. Tonight's thought is a strange one, but also the kind that can quietly settle into your mind and stay there long after you first heard it. It's not about what's happening in the news or what's trending in science right now. It's about the kind of question you might stumble across late at night when the house is still, when your thoughts wander a little further than usual. It's about whether the very first civilization on Earth was ours at all. That probably sounds like the opening line of a science fiction novel, something involving alien visitors or lost continents that sank beneath the sea. But what I mean is closer to home than that. Imagine the long history of our planet, billions of years of it, stretching so far back that our entire human story, every kingdom, every invention, every person you've ever read about, fits into only the last tiny sliver of that timeline. The rest of it is filled with oceans and volcanoes, forests and ice. Creatures will never meet except through fossils and perhaps, just perhaps, something else. Something that thought and planned and built long before the first humans ever picked up a tool. Before we go any further, I'd like to know where you're listening from. Are you in a place where the night has already wrapped itself around you? Or is there sunlight coming through your window right now? Maybe you're on a long journey, the world moving quietly past you, or maybe you're sitting still in the one chair that always feels like yours. Wherever you are, and whenever it is for you, you and I are meeting here in this shared moment to lean into an idea that asks us to imagine a world we can't see anymore. If this journey feels like the kind of company you've been looking for, calm, steady, curious without being in a hurry, I'd be grateful if you gave it a like, or subscribed, or even passed it along to someone who might need a few gentle thoughts tonight. It's a small thing, but it helps keep these quiet conversations reaching new ears, and in some way, it's a little like keeping a light in the window for fellow travellers. So let's start somewhere simple, by thinking about the Earth itself. Not the Earth as you and I know it now, but the Earth as it was before any people walked across it. There were no cities, no fields, no roads, no voices that sounded like ours. There were skies, there were seas, there were endless coastlines that have shifted and reshaped themselves over and over again. Entire mountain ranges have risen up and worn down again in the time before the first humans arrived. If you looked at a map of the continents back then, it wouldn't look like the one you've seen in school books. Landmasses drift across the planet's surface over millions of years, colliding, breaking apart, vanishing under the sea. It's easy to think of this pre-human Earth as empty, but it wasn't empty at all. It was alive with creatures filling every corner, every niche. Some swam, some flew, some crept along the forest floor. Many of them were nothing like anything alive today, and some of them, just maybe, had the beginnings of something we'd recognize as intelligence. We tend to think of human intelligence as the single unique thing that separates us from all the other species, but the truth is that intelligence is scattered across the animal kingdom in surprising ways. Crows and parrots solve puzzles. Dolphins recognize themselves in mirrors. Octopuses use tools. That's in the world as it is now, with us in it. But what if there was a time when intelligence didn't just flicker in scattered individuals, but became the foundation for a whole civilization, one that rose and fell before we were ever here to see it? The trouble is, the Earth is a forgetful host. It keeps some secrets for a very long time, and it erases others almost immediately. A city built today, if left abandoned, starts to crumble in just a few decades. In a few hundred years, it might be nothing but ruins overgrown with plants. In a few thousand, the last obvious traces could be gone. Give it a few million years and the ground will have shifted, weather will have worn down stone, rivers and seas will have changed course. Even metal and concrete would be broken apart, scattered, and buried under new layers of earth. It's not that the evidence would be destroyed on purpose, but that the planet is constantly turning over its own pages, writing new layers on top of old ones. If an earlier civilization had existed millions of years ago, would we even know it? We'd like to think so. We imagine archaeologists digging down to find stone temples, sculptures, tools. But that works for human history because we're only looking back a short way. The oldest stone structures built by humans are only about 12,000 years old. That's barely anything compared to the Earth's age. If we tried to find something from, say, 50 million years ago, we'd be looking in rocks that formed back when that civilization's cities were still standing. And those rocks have been through a lot since then. They've been compressed, twisted, broken, melted. They've been carried miles from where they first formed. The older the layer, the less it remembers. This is part of why scientists sometimes talk about what's called the Silurian hypothesis. The name comes from a bit of science fiction, but the idea is a serious one. It asks whether we could detect an industrial civilization in the geological record millions of years later, even if there were no direct artifacts left. Would there be chemical traces, layers of unusual metals, changes in the composition of the atmosphere? Maybe so. We know that our own industry has already left a signature in ice cores, in sediments, in the thin layer of radioactive isotopes from nuclear testing. Those things could last for millions of years, long after the buildings have vanished, but they're subtle and easy to miss unless you know exactly what you're looking for. If that's true, it raises an odd possibility. Maybe we've already walked past the faint traces of something older without realizing it. A streak of metal in a cliff face, a mineral deposit with an unusual composition. We might have classified it as a natural feature without ever considering that it could be artificial. That's not because scientists aren't looking. It's because the idea of a pre-human civilization is so far outside the normal range of possibilities that it isn't the first explanation anyone would reach for. Thinking about this doesn't mean we have to believe in secret histories or hidden conspiracies. It's just an exercise in humility. We like to think of ourselves as the first, the only, the pinnacle of life on Earth. But we are part of a much bigger story, one that's still being written, and one that has already seen more change and upheaval than we can easily picture. We know that mass extinctions have reshaped life again and again. We know that ecosystems can rise and collapse in what's, geologically speaking, an instant. And we know that intelligence isn't a straight ladder with us at the top. It's a branching, tangled network that's grown in many directions over time. So if there was a civilization before us, what would it have been like? That's the question we'll start walking toward next. For now, it's enough to simply hold the idea in your mind, to picture the deep past as something richer and stranger than the empty wilderness we sometimes imagine. The continents weren't where they are now. The air might have felt heavier, warmer, or colder. The animals would have been unrecognizable, and somewhere in all that, perhaps there were minds working together, shaping their environment, telling their own stories, and then disappearing before we ever had the chance to meet them. Before there were people to write dates down, before there were calendars or clocks, before even the idea of keeping track of years existed, the Earth was already old. By the time the first humans appeared, the planet had lived through billions of sunrises and sunsets, long enough to wear down entire mountain ranges, long enough to raise others from the seabed. The continents you see on maps today were not fixed in place. They wandered slowly, colliding, breaking apart, drifting across the globe like enormous stony rafts on a sea of molten rock. If you could have looked at the world from space tens of millions of years ago, the outlines would have been unfamiliar. There would still have been blues and greens and whites from clouds, but the shapes of the land would have been strange, and the arrangement of oceans would have drawn patterns you'd never seen before. The climate was not always what we know now. There were stretches of time when much of the planet was warm and wet, covered in lush forests that reached almost to the poles. There were other times when ice spread so far south that even the equator felt the chill. Seas rose and fell over and over, drowning coastal plains and later revealing them again. Whole ecosystems came and went in cycles we can only piece together from the rock record. The Earth never stood still, and it never will. In those vast ages, life filled almost every possible corner of the planet. The ocean floors teemed with creatures that never saw the sun. Coral reefs grew and died and grew again in new places. Swamps rang with the calls of animals we'd struggle to imagine without the help of fossils. On land, there were forests filled with trees whose closest relatives are gone now, and beneath their branches moved creatures of every size. Insects were among the oldest of them, long established by the time dinosaurs appeared. Birds evolved from small feathered dinosaurs and learned to ride the winds that shifted above the forests. Mammals were there too, though for much of the time they were small, often living in the shadows of much larger neighbours. If you could stand in one of those ancient landscapes, it might feel familiar at first. A tree is still a tree, and water still flows downhill. The air would still move in breezes and rush in storms. The sun would still climb in the morning and sink at night. But the details would be deeply unfamiliar. The sounds would not match what your ears are used to. The plants might be close to what you know, or they might be alien in shape, leaf patterns that evolve for climates that no longer exist. The animals would be a mix of the recognizable and the strange, some ancestors of creatures alive today, others that left no descendants at all. Some of these species lived in herds, flocks, and colonies. They communicated in ways that are lost to us, using sounds or colours or movements that meant something to them and nothing to us now. They hunted, they migrated, they raised their young. Many had brains capable of complex behaviours, though perhaps not in ways we would immediately call civilised. And yet, when we think about the possibility of a pre-human civilization, this is where the mind begins to linger. Somewhere among all those forms of life, could there have been one that took a different path? One that began to change its environment in deliberate ways, not just for survival, but for comfort, for art, for the satisfaction of curiosity. We know it's possible for such things to happen because it happened with us. Our own path from small bands of hunter-gatherers to builders of cities took hundreds of thousands of years. Intelligence did not appear overnight. It was shaped by climate, by geography, by the constant pressures of survival and adaptation. We can imagine that if another species had found itself with the right combination of abilities, problem-solving, communication, the use of tools, something similar could have begun in the deep past. Not in our timeline, but in one of the many others that existed before we were here. The trouble is that the record of these times is incomplete. Fossils are rare, and they form only under certain conditions. Most living things vanish without a trace when they die. They remain scattered, eaten, or decomposed. Even when bones are preserved, they tell us little about behaviour. A skeleton can reveal the size and shape of a brain cavity, but not what thoughts pass through it. It can hint at movement, diet, and lifespan, but not the complexity of culture. Stone tools and structures survive better, but only if they're buried in a way that shields them from erosion and tectonic activity for millions of years. And so much of the Earth's surface has been recycled. The crust is not a permanent stage, but a shifting set of platforms. Oceans open and close, swallowing old seabeds and creating new ones. Mountains are ground down into sand and gravel, carried away by rivers, spread out in new layers elsewhere. Any trace of a civilization that existed before us would have had to survive all of that, and the odds of that happening are small. Even if it did survive, we would still need to recognize it for what it was. A worked piece of stone from tens of millions of years ago might be dismissed as natural unless it was found in the right context. A smudge of unusual chemistry in a rock layer might be passed over unless someone thought to look for industrial causes. When you think about the scale of time involved, it becomes easier to see how something could disappear almost entirely. Imagine an entire continent covered in forests, dotted with towns and cities belonging to a species that never met us. Over millions of years, sea levels rise and fall, glaciers advance and retreat, volcanoes erupt, and the ground itself buckles and shifts. In the end, almost everything they made is gone. A few stubborn traces are left, maybe buried deep under layers of sediment, maybe trapped in an ancient seabed now turned to stone. The rest is as if it never happened. We can point to places where the Earth has held onto a memory for far longer than usual. Fossilized forests where the trees still stand, turned to stone. Insects trapped in amber for tens of millions of years. Footprints pressed into mud and preserved until the mud became rock. These are accidents, moments in time saved by unusual conditions. For a whole civilization to be recorded like that, it would take a remarkable combination of luck and geology. Without it, their existence would slip away into the same silence that has swallowed so many other species. Thinking about this doesn't require us to believe it happened. It just opens the door to the possibility. And once that door is open, it's hard not to wonder what such a civilization might have looked like. Would they have lived in great numbers or in small scattered communities? Would they have built in stone or in wood or in materials that decay too quickly to leave much behind? Would they have shaped the land to suit their needs or moved with the seasons, leaving only light marks on the world? Would their art have been something we could recognize, or would it have been expressed in colours and forms that made sense only to them? We don't have answers, but we do have the ability to imagine, and imagination is sometimes the first step toward discovery. Scientists form hypotheses not just from evidence, but from ideas about what evidence to look for. And ideas like this one, about the possibility of a pre-human civilization, can change the kinds of questions we ask when we study the past. The Earth has been many different worlds over its lifetime. Each version had its own climate, its own landscapes, its own collection of life. The version we know now, with its mix of oceans, continents and polar ice caps, is just one in a long series. Long before we arrived, there were jungles where there is now desert, ice where there is now open sea. There were animals whose shapes we would barely recognize, and plants that would look out of place in any modern forest. Somewhere in all that change, it is not impossible to imagine that intelligence rose before, lived its span, and then was gone. And if it did, then the Earth itself is the only witness that remains. Long before we appeared, the Earth was not silent. It was full of sounds that belonged entirely to other species. The rush of wind through plants that no longer exist, the low calls of animals whose bones are the only part of them we can still find, the shifting, grinding and trickling of water carving its way through landscapes that would have been unrecognizable to us. Somewhere in that mix there may have been minds that worked in ways we would understand, minds that noticed patterns, that remembered things not just for survival, but for their own sake, that imagined outcomes before they happened. Minds that dreamed. It is tempting to think of dreaming as something uniquely human, tied to our ability to tell stories and picture things that are not right in front of us. But animals dream. We know this from the way their brains behave during sleep, from the way dogs twitch their paws as if running, or birds move their eyes beneath closed lids. Dreaming seems to be something brains do when they have enough complexity to process memory and imagine different possibilities. It does not require a language like ours. It does not require cities or books. It simply requires a nervous system capable of weaving together experiences into something more than a replay. If that is true, then there could have been many species before us that dreamed. Most of them, we would expect, dreamed in ways shaped by their own needs. Dreams about hunting, about avoiding predators, about finding shelter. But a few might have taken dreaming further, the way we did. They might have imagined things that had never happened. They might have pictured tools, new ways to get food, new ways to protect themselves. Those kinds of dreams, repeated over generations, can change the way a species lives. Once you have a mind that can imagine something different from what it has, you have the seed of invention. The step from using a found object as a tool to shaping an object for a specific purpose is small in evolutionary terms, but enormous in its consequences. It means you're no longer entirely at the mercy of your environment. You can begin to change it. You can build. You can prepare for things that have not yet happened. And if you share that skill with others, you can pass it along, refine it, and create traditions that last beyond a single lifetime. We have seen the beginnings of this in the species alive today. Chimpanzees teach each other how to strip leaves from a branch to make a tool for gathering termites. Certain birds learn how to bend bits of wire to reach food, and that knowledge spreads through the group. Dolphins develop unique hunting techniques in particular regions, passing them down to their young. These are the building blocks of culture, and they exist outside humanity. They show us that intelligence is not an all-or-nothing quality, but a spectrum, and that we are part of a much larger family of problem solvers. If we take that understanding and look back into the deep past, it is not hard to imagine that some branch of life might have reached a level of cooperation, planning, and innovation far beyond what we see in other species today. The difference between clever tool use and civilization is one of degree and time. It requires a stable environment long enough for ideas to accumulate, for techniques to improve, for knowledge to spread widely enough that it becomes part of the fabric of life. Given millions of years, even a modest start could lead to something remarkable. But what would it take for that leap to happen? Large brains help, but they are not everything. Social structure matters. Intelligence grows when there is a need to understand and predict the behavior of others. Communication matters. The ability to share ideas quickly means that discoveries are not lost when one individual dies. Curiosity matters. The drive to explore beyond the immediate needs of survival can lead to new possibilities. In our own case, all of these things aligned. Perhaps they aligned before in some other lineage, under different skies, surrounded by different creatures. We often imagine intelligence taking the same shape it has in us. Upright posture, hands with fine motor control, eyes that face forward, a voice capable of complex sounds. But those are just the tools our particular body plan offers. Another species might have built its intelligence on different foundations. It might have worked in the water, using fins or tentacles to manipulate its environment. It might have flown, using its perspective from above to navigate and plan. It might have been small, relying on numbers and cooperation rather than size and strength. Intelligence is adaptable. It finds ways to express itself through whatever form it has. If there were such a species, its dreams might have been as varied as ours. Perhaps they imagine better ways to catch food, or safer ways to raise their young. Perhaps they told each other stories, even if those stories took a form we would not recognize as language. Perhaps they decorated their shelters, or created sounds or patterns simply because they enjoyed them. Art is one of the most mysterious signs of intelligence because it is not strictly necessary for survival. It suggests a mind that values beauty or symbolism, or the act of creation itself. That is the kind of mind that might leave traces worth finding. Of course, most dreams never leave a physical mark. Even in our own history, the majority of what we think and imagine vanishes the moment we wake. Civilizations leave behind only a fraction of what they create, and that fraction is vulnerable to time. The older the evidence, the more likely it is to be erased. So if the first minds that dreamed also built, they would need to have built in ways that could survive the slow erosion of the ages. Stone lasts longer than wood. Fired clay lasts longer than woven fibres. Metal can endure, but it can also corrode completely given enough time. Without preservation, most of what any civilization makes will eventually disappear. This is where the difficulty of proving such a thing becomes clear. Even in our own cities, built with all the technology we have, the process of decay starts quickly. Without maintenance, roads crack and buildings crumble. In a few centuries, the outlines of streets might still be visible from the air, but in a few thousand years, the ground might have swallowed them entirely. In a million years, they could be nothing more than faint differences in soil composition. In tens of millions, they might be gone beyond recognition. That is why, when scientists consider the possibility of an earlier civilization, they often look for indirect signs. Changes in the chemistry of rocks, sudden shifts in climate that could be linked to industrial activity, deposits of materials that do not occur naturally. These things are less vulnerable to erosion than a building or a tool. They are the geological equivalents of footprints on a very old path. But even those are rare, and nature produces strange results on its own. Separating what is artificial from what is natural can be a challenge, especially when you're looking back tens of millions of years. Still, the thought remains. Somewhere, at some point in the Earth's history, it is not beyond possibility that the first minds capable of dreaming in the way we do took the first steps towards something greater. Maybe they lived in small groups at first, scattered across a landscape full of predators and changing weather. Maybe they learned to shelter in caves or to build nests or platforms that lasted beyond a single season. Maybe they began to use fire or some other form of controlled energy. With each step, their world would have changed, and with each change, the gap between their lives and those of the other creatures around them would have grown. If they reached the point where they could alter their environment on a large scale, they might have spread into new territories, adapting to different climates and resources. Trade could have emerged, even if it was nothing more than the exchange of rare materials or food between groups. Over time, their knowledge could have accumulated until they had something like our early cities, centres where ideas, goods and skills came together. The details are unknowable, but the path is familiar. It is the one we walked, and the one that evolution could have laid down more than once. Whether they left anything we could find today is another matter. The record of life on Earth is full of gaps, even for species we know existed. Most of the story is missing, with only scattered fragments remaining to hint at what was once there. That is why this idea is so hard to prove or disprove. The absence of evidence is not evidence of absence. It is simply the result of how the planet works. Time is always moving, always reshaping, always covering the traces of what came before. And so we can only imagine the first minds that dreamed, picture them in landscapes that are long gone, hear their voices in sounds we can no longer translate. They might have been nothing like us, or they might have shared more than we expect. The possibility is enough to remind us that our place in history is not guaranteed to be unique. Intelligence may be rare, but it may not be singular. The Earth may have hosted it before, and it may again. From here, the question becomes not just whether it could have happened, but what we even mean when we say civilization. When we use the word civilization, it's easy to picture tall stone buildings, wide roads, and intricate art carved into walls. We think of writing, laws, and governments, of great gatherings of people building something bigger than any single individual. But those are just the familiar examples from our own past. Strip the word down to its essence, and it's not about a specific style of architecture or a particular kind of government. It's about a way of living where knowledge, culture, and technology accumulate over generations, and where that accumulation changes the way a society functions. By that measure, civilization isn't necessarily tied to how a place looks from the outside. A group could live in structures made entirely of natural materials, leaving no grand ruins behind, and still be a civilization if they have organized systems, shared knowledge, and ways of shaping the environment to their needs. We tend to imagine stone monuments because they last the longest, but permanence isn't the true measure. Complexity is. It's also worth noting that civilizations can be small. We often think in terms of empires, nations, and vast cities because those are the easiest to spot in our own history. But human civilization didn't start there. It began in scattered communities, connected by trade and shared practices, with no central authority binding them together. What made them part of the same broad story was the way they exchanged ideas, passed down techniques, and created a cultural memory that lasted beyond any single lifetime. So if we ask whether there might have been a civilization on Earth before humans, we have to keep that flexibility in mind. It might not have looked like Rome or Mesopotamia. It might not have been based on agriculture. It might have relied on entirely different resources suited to the species that built it. Even the concept of a city might have been different. Perhaps not a dense cluster of permanent buildings, but a network of seasonal gathering places, connected by routes that were well known to those who travelled them. One of the biggest challenges in defining civilization is that we tend to measure it by our own standards. We count writing as a major milestone, but writing is just one way of storing and transmitting knowledge. Oral traditions can be highly complex and accurate over long periods of time. We value monumental architecture, but a society could create equally sophisticated achievements in forms that vanish quickly, like woven structures, carved wood, or even arrangements of plants. We admire large-scale engineering projects, but small, precise interventions in an environment can be just as telling. If a non-human civilization existed millions of years ago, it's possible that their way of life wouldn't fit neatly into our categories. They might not have farmed in rows or herded animals in pastures. They might not have left behind pottery or metal tools. They could have worked entirely with organic materials, using techniques that left no obvious trace once those materials decayed. In that case, the evidence of their existence would be more likely to appear as subtle patterns in the landscape, altered waterways, unusual soil compositions, or the sudden appearance of certain plant species far from their native ranges. This is where the definition of civilization matters so much. If we limit it to what we already recognize from human history, we risk missing signs of other possibilities. If we expand it to include any sustained, organized way of life that shapes the environment and preserves knowledge, we open ourselves to a wider range of evidence. That doesn't mean we should call every animal society a civilization. Ants and bees have complex social structures, but they operate almost entirely on instinct, without the kind of cultural evolution we see in humans. The key difference is innovation that builds on itself, producing changes over time that aren't just genetic but learned and shared. Consider how archaeologists determine whether a past human group was part of a civilization. They look for signs of long-distance trade, specialized labor, symbolic expression, and the ability to support communities larger than the immediate family group. None of these require stone buildings. None require metal. They simply require organization, cooperation, and shared culture. These are the markers that could, in theory, appear in the fossil record of a non-human species, though finding them would be difficult without direct artifacts. There's also the question of how long a civilization needs to last before we consider it significant. Some human civilizations have endured for thousands of years, while others have risen and fallen within a few centuries. In geological terms, even 1,000 years is barely a flicker. But during that time, the impact can be enormous. Forests cut down, rivers diverted, species moved from one continent to another. Those changes can sometimes be detected in sediment layers, giving us hints about human activity long after the buildings are gone. If a pre-human civilization lasted long enough to alter ecosystems on a large scale, we might expect to see similar traces, even if we didn't recognize them as such. Of course, one of the dangers of this kind of thinking is that nature itself can produce patterns that look artificial. A perfectly round hill might be the remains of an ancient volcano rather than a constructed mound. Straight lines in rock formations can form through natural fracturing. Even large-scale changes in vegetation could be caused by climate shifts rather than deliberate planting. This means that to identify a true civilization, we would need multiple lines of evidence. Changes in the land, unusual material deposits, and possibly even fossilized remains of the species itself, showing signs of behavior beyond the ordinary. And that leads to another consideration. What would the members of this civilization have been like physically? We often assume that intelligence requires a body capable of fine manipulation, like hands or tentacles. That's because most of our technology is built with such tools in mind. But if a civilization evolved with different capabilities, it might have developed technologies that look nothing like ours, perhaps based more on shaping large environments than on crafting small objects. They could have been aquatic, using their environment in ways we'd struggle to reconstruct from the fossil record. They could have been flighted, building temporary structures in trees or cliffs. Their intelligence might have been expressed in architecture made entirely of living materials that changed over time. The difficulty of defining civilization is partly why the question of a pre-human one is so intriguing. It forces us to think about intelligence and culture without the comfortable reference points of our own history. It asks us to imagine forms of organization and creation that we might overlook if we were only looking for stone cities and bronze tools. It reminds us that our way is just one among many possible ways, and that the rules we think are universal might only be local customs of our species. Even now, when we look at life around us, we can see glimpses of alternative paths. Elephants shape their environment by knocking down trees and digging water holes, changes that last long after the individuals are gone. Some bird species build elaborate structures to attract mates, structures that can be reused and added to over time. Whales communicate across vast distances, their songs carrying information that may shift with the seasons and years. None of these quite cross the threshold into civilization as we define it, but they show how close other species can come to the edge of it. In a different context, with different pressures and more time, those edges could be crossed. Once we accept that civilization might not always look like ours, the next question becomes how we would even begin to search for it in the deep past. That search wouldn't start with obvious ruins. It would start with subtle anomalies in the geological and fossil records. It would require scientists from many fields to compare notes, to look at data with fresh eyes, to ask whether an odd finding might be the product of deliberate action rather than chance. That's a slow, careful process, and one that could just as easily confirm a natural explanation as it could reveal something unexpected. The challenge is enormous, but so is the timescale we're talking about. Earth has had billions of years to host experiments in life. We know of at least one that produced a civilization, ours. It's not unreasonable to wonder whether there might have been another. Whether it left marks we can still find depends on how we define those marks, and whether we're willing to see them in forms we didn't expect. Which brings us to the question of what signs we could actually detect if such a thing had happened. When people imagine uncovering the distant past, they often picture paleontologists standing over a perfectly preserved skeleton, brushing away the last bits of soil to reveal a creature as if it had just fallen asleep a moment ago. The truth is less dramatic and far more fragile. Most of the past is gone. What survives is a scatter of clues, incomplete and altered, often compressed into forms that no longer look much like what they once were. The scientists who study them work more like translators than treasure hunters. They are reading a language that the Earth has been writing for hundreds of millions of years in a script shaped by pressure, heat, and time. A fossil is not a thing frozen in place. It's a transformation, a kind of substitution. The original bone, shell, or leaf is replaced molecule by molecule with minerals that seep in over ages, hardening into stone. Sometimes only the impression remains, a cast of the outside shape, a shadow of a footprint, a ripple in the mud that hardened before it could be disturbed. And just as often, those delicate traces never form at all. They're washed away, broken, or buried so deep they'll never return to the surface. This is why the fossil record is patchy. Whole species can live and vanish without leaving behind a single preserved example for us to find. The conditions that produce fossils are rare, and they tend to occur in specific environments: river deltas, lake beds, volcanic ash falls, and seafloors where sediment collects rapidly. In dry uplands or shifting coasts, remains are far more likely to be destroyed before they can be preserved. That means our picture of the past is built from scattered pieces, biased toward the kinds of places that protect them. For someone looking for signs of an ancient civilization, that bias is an enormous problem. Even in the short span of human history, our footprint is uneven. Cities in deserts or floodplains can leave durable remains, while coastal settlements might be erased by rising seas or buried under layers of sediment. Now stretch that over millions of years and imagine how much could vanish entirely. If an advanced society had existed in a region that later became ocean floor, its traces might now be locked under miles of water and mud, beyond the reach of most exploration. If it lived in a forested lowland later scoured by glaciers, it could be wiped so clean that even the landforms are unrecognizable. The people who sift through the Earth's layers for evidence know this. They work with the understanding that every discovery is just one point in a vast, mostly invisible web of life that used to exist. They also know that some of the most important finds don't come from complete specimens, but from tiny fragments. A single tooth can reveal diet, age, and evolutionary relationships. A thin layer of pollen trapped in sediment can tell the story of ancient climates and vegetation. Chemical signatures in rock can hint at events like volcanic eruptions, asteroid impacts, or even sudden unexplained shifts in atmospheric composition. Those unexplained shifts are the sort of thing that might point to something unusual, perhaps even to the influence of a civilization. Our own industrial activity has already altered the chemical composition of the atmosphere in measurable ways, leaving a layer of carbon isotopes that will be detectable far into the future. Plastics, metals, and synthetic compounds are spreading into sediments around the globe. Even if all our buildings vanished tomorrow, those traces would remain in the geological record for millions of years. The challenge, of course, is that nature can also produce strange patterns in chemistry and sediment. Massive volcanic events can flood the atmosphere with carbon and sulfur. Large-scale die-offs can leave layers rich in certain elements. Shifts in ocean currents can redistribute sediments in unusual ways. The fossil whisperers, as you might call them, have to weigh every possibility before considering the most extraordinary explanations. In science, extraordinary explanations require extraordinary evidence. Still, there are moments when the evidence resists the simplest answers. In certain rock layers, scientists have found sudden changes in mineral composition that suggest a rapid introduction of unusual materials, ones that don't seem to fit the slow processes of erosion and deposition. Most of these turn out to have natural explanations, but each time the question lingers. What if? What if, long before us, there was another hand at work, shaping the environment in ways we don't yet recognize? Finding something like that wouldn't necessarily be as obvious as unearthing a carved statue or a worked piece of metal. It might be subtler. Patterns in the distribution of minerals that hint at large-scale extraction, deposits of rare compounds that suggest deliberate manufacturing, or a thin layer of material whose origin can't be explained by known natural processes. Interpreting such patterns would require not only geology, but chemistry, archaeology, and even an openness to asking questions that sound improbable. There's a patience to this kind of work. Decoding the past isn't a matter of pulling one artifact from the ground and declaring the mystery solved. It's about assembling a body of evidence piece by piece until a picture starts to form. And in the case of a possible pre-human civilization, the picture might never be complete. It could be nothing more than hints that refuse to fade, inviting speculation without ever confirming it. That uncertainty is part of the fascination. We live in a time when it's easy to think of the past as something we can map and measure, but in truth our knowledge is thin. The fossil record is not a complete history. It's a set of surviving fragments, scattered across the globe, written in a language we're still learning to read. What it tells us is that life has taken forms stranger and more diverse than we might have guessed, that entire branches of the evolutionary tree have grown and withered without leaving much trace, and that the world we know is just the latest version of a planet that has reinvented itself countless times. In that light, the idea of another civilization, lost so completely that it survives only in faint geological whispers, doesn't seem entirely impossible. If it existed in a time and place where fossilization was rare, if it relied on materials that decay quickly, if its population was small enough to avoid leaving massive global changes, its traces could be as elusive as the memory of a season long past. The scientists who study deep time know this, and it shapes how they look at the ground beneath their feet. Every layer of rock, every core sample pulled from the sea floor, every stratum in a cliff face is a chapter in the Earth's story, but the pages are worn, torn, and often missing entirely. To read them well requires not only technical skill, but imagination, the ability to see how a faint trace might connect to a larger pattern. And sometimes, just sometimes, it requires the willingness to consider the most unlikely possibility. That willingness doesn't mean jumping to conclusions. It means leaving a little space for the unknown, for the chance that the Earth's long memory might still hold surprises we haven't yet learned how to recognize. From here, the question becomes how the planet itself might preserve, or erase, those surprises, and what forces could quietly remove nearly all evidence of something that once was. The Earth remembers, but not the way we do. Our memories are collections of moments, snapshots we can revisit, sometimes vivid, sometimes blurred. The planet's memory is slower, heavier, written in stone and ice and sediment. It keeps records in layers, each one built from the debris of what came before. But it's also a forgetful memory, constantly rewriting itself, sanding down old impressions, burying some completely under the weight of new ones. It has no sense of nostalgia, no attachment to preserving a scene for the sake of sentiment. It changes because that's what it has always done. If we could peel the crust of the Earth back like the pages of a book, we'd see a story with long chapters missing. Whole periods of time are gone, erased not because they were unimportant, but because the processes that shape the planet are relentless. Mountains rise when tectonic plates collide, then crumble under wind and rain. Oceans spread when plates drift apart, then shrink again as land closes in. Volcanoes pour out layers of new rock, covering whatever was there before. Ice sheets grind across continents, stripping away the surface like sandpaper. Even the quiet work of rivers, carrying silt from one place to another, can bury old landscapes and create new ones. The surface we see today is not the same one that existed 1 million years ago, or 10 million, or 100 million. Every place has been reshaped over and over. In some regions, the rocks at the surface today might have formed only a few thousand years ago. In others, they might be hundreds of millions of years old, but have been altered so much that any trace of what they once recorded is nearly gone. This constant recycling of the crust means that the older something is, the less likely it is to survive in a form we can recognize. For the traces of any civilization to last beyond a few tens of millions of years, they would need extraordinary luck. They would have to be preserved in a stable geological setting, one that was not submerged, crushed, or scraped away. Even then, the evidence might be distorted. Heat and pressure can change the structure of rock, melting or warping anything embedded in it. Organic materials decay quickly unless sealed away from air and moisture, and even then time works against them. This is why so much of Earth's early history is known only in outline. The first billion years of the planet's existence are represented by only a few surviving fragments of rock, scattered in places like Greenland and Western Australia. These are the barest hints of what was happening then. The rest is gone, recycled into the mantle, and brought back as new rock without the original markings. The same principle applies to more recent times, just on a smaller scale. It's not only geology that erases the past. Climate and biology can be just as thorough. A jungle can reclaim a city in a matter of decades, hiding it under layers of soil, vines and trees. Insects and microbes dismantle wood, leather and cloth. Salt water corrodes metal. Even stone can be eaten away by plants, rain and frost. On a human time scale, ruins may seem permanent, but compared to the lifespan of the planet, they are brief interruptions. If we vanish tomorrow, the most visible signs of our presence, roads, buildings, bridges, would be fading within a century. In 10,000 years, most would be gone or unrecognizable. In 1 million years, only scattered traces might remain, buried deep in sediments or transformed into minerals. After 10 million years, the changes we made to the land might be visible only in subtle patterns. A straightened river here, a deposit of unusual elements there. The rest would be overwritten by the slow processes that never stop. That's what makes the search for deep history so challenging. We aren't looking for intact artifacts, but for fragments that have survived in spite of everything working against them. And the older we look, the more we have to accept that the record will be incomplete, maybe hopelessly so. There are entire continents worth of history we will never know, not because it's hidden from us, but because it's gone in every meaningful sense. Even the ocean floor, which might seem like a safe place to store the past, is constantly renewed. The crust beneath the deep oceans is young by geological standards, no more than about 200 million years old in most places, because it's continuously pushed back into the mantle at subduction zones. That means anything older than that, no matter how well preserved at the time, has been destroyed. Land can survive longer, but it's far from immune. Uplift and erosion reshape it, and the shifting of continents changes coastlines and climate in ways that erase what was there before. This turnover is part of why the fossil record contains so many gaps. It's not that life was absent during those times, it's that the conditions didn't allow for preservation. If you think of the Earth as a library, it's one where entire shelves of books have been burned, rewritten, or rebound into other volumes. What remains are scattered chapters, sometimes with missing pages, sometimes with text so weathered it's hard to make out the original meaning, and yet this imperfect memory is all we have to work with. The scientists who study it are constantly weighing what's preserved against what's missing, trying to reconstruct a story from uneven evidence. When they find a fossil in good condition, it's because of a rare alignment of circumstances: quick burial, stable conditions, protection from scavengers and decay. The same would be true for any artifact of a civilization. It would have to be buried rapidly and in a place where it could avoid destruction for millions of years. Even then, recognition would be a hurdle. A worked piece of stone could be mistaken for a natural formation. A strange mineral deposit could be dismissed as the result of unusual but natural chemistry. Without a clear context, a set of associated finds that all point in the same direction, it would be easy to overlook or misinterpret the evidence. That's why thinking about the planet's memory changes how we think about the possibility of a lost civilization. It's not enough to imagine what they might have built. We have to imagine how those things would interact with the forces of erosion, subduction, and decay over unimaginable spans of time. We have to picture what would survive and in what form, and we have to accept that most of it would not survive at all. What the planet does remember, it remembers in ways we can measure. Chemical traces locked in rocks, tiny fossils sealed in amber, impressions of leaves or shells pressed into ancient mud. These are the fragments that slip through the constant rewriting of the surface. They are precious not because they give us a complete picture, but because they give us any picture at all. The rest is lost, as if it never happened. And that, more than anything, is why we can't be certain what the Earth has hosted before us. If the planet is capable of wiping away almost everything we've done in a few million years, then it's capable of having done the same to others. Its memory is long, but it's selective, and it keeps its secrets well. If there were others before us, beings who dreamed, built, and vanished, their presence would now be little more than the faintest of signatures, if that. The question is whether we've already passed over some of those signatures without recognizing them, or whether they're still buried, waiting for the right conditions to be uncovered. That possibility leads naturally to the next thought. If the planet has hosted intelligence before, what kind of life might have been capable of it? When we picture the age of reptiles, most of us imagine dinosaurs as they appear in museum displays or films. Towering predators with teeth like knives, long-necked giants moving through swamps, herds of plated herbivores swaying their tails like living fortresses. It's a view dominated by size and spectacle, a world where brute strength seems to rule. But the reign of the reptiles lasted for more than 160 million years, and in all that time there was room for much more than size. There were niches for creatures that were small, quick and clever, for hunters that relied on precision as much as power, for opportunists that could adapt to changing environments in ways that hint at something more than instinct. If we're going to wonder about a civilization that predates our own, the Mesozoic era, when dinosaurs were at their peak, is one of the first places curiosity turns. Not because we imagine city-building tyrannosaurs, but because evolution had time to explore countless forms during that span. The variety of life was extraordinary. There were flying reptiles that could cross whole seas, aquatic reptiles that ruled the oceans, and land dwellers that ranged from the size of a chicken to the length of several buses. Among them were small, lightly built species with brains proportionally larger than those of their enormous relatives. Brain size alone doesn't determine intelligence, but it offers clues. In modern animals, there's a rough pattern. Species with higher brain-to-body ratios often show more complex behaviours, better problem-solving, and more adaptability. Some of the smaller theropod dinosaurs, especially those closely related to birds, had relatively large brains for their size. They had keen vision, good coordination, and in some cases, evidence suggests they may have hunted cooperatively or cared for their young. These are the kinds of traits that, given enough evolutionary time, could form the basis for more advanced social structures. Birds, after all, are living dinosaurs, and some of them, like crows and parrots, are capable of remarkable problem-solving. They use tools, recognize themselves in mirrors, and pass learned behaviors through generations. If modern birds can do this, it's not impossible that their ancestors might have had similar capacities, perhaps even greater, in some lineages that are now extinct. The problem is that intelligence, in the sense we mean it here, leaves little direct trace in the fossil record. A fossil can show us the shape of a skull, from which we can infer brain size and structure, but it can't show us how an animal thought, communicated, or planned. We have to look for indirect clues, evidence of social behaviour in trackways, signs of nesting colonies, patterns of distribution that suggest migration or complex hunting strategies. These hints exist for some dinosaur species, but they're far from conclusive. Even if a highly intelligent dinosaur lineage had existed, the leap from intelligence to civilization is enormous. It would have required not just cleverness, but the ability to manipulate the environment in lasting ways. That raises the question of anatomy. Dinosaurs, as far as we know, didn't have manipulative limbs like our hands. Some had grasping claws, and their descendants, birds, have dexterous beaks and feet. But crafting tools in the way humans do might have been challenging. That doesn't mean it was impossible. They might have developed technologies suited to their own bodies, arranging materials with their feet and mouths, using natural features of the landscape as tools, or even working cooperatively to build structures. If such a civilization had existed, what would it have looked like? It's tempting to imagine settlements built in sheltered valleys or along rivers, perhaps made from plant materials, mud, or stone. They might have created elevated platforms to avoid floods, or constructed nesting grounds that were maintained and expanded over generations. Their art, if they had it, could have taken forms we wouldn't immediately recognize, arrangements of feathers, shells, or coloured minerals, patterns scratched into the ground or carved into soft surfaces. The difficulty, as always, is preservation. Organic materials like wood and plant fibres decay quickly, and even stone structures can be erased over millions of years. In the time since the last non-avian dinosaurs lived, continents have shifted, mountains have risen and worn away, and oceans have opened and closed. Anything they built would have had to survive all of that, and the chances are slim. We might never know if such structures existed unless they left behind more durable signs, such as changes in the distribution of certain minerals or evidence of large-scale environmental modification. And yet, the reign of the reptiles was long enough to allow for many experiments in evolution. Our own lineage has produced tool-making intelligence only once, but that's in a fraction of the time dinosaurs were around. It's not unreasonable to think that somewhere in that vast span, a lineage could have developed not just intelligence but culture. Whether it happened or not is another matter, but the possibility can't be entirely dismissed. It's also worth remembering that we tend to see dinosaurs as primitive compared to mammals, a bias that comes from the fact that mammals dominate the world now. But during the Mesozoic, mammals were the small, furtive creatures, living in the shadows. Dinosaurs were the ones filling almost every niche on land. If intelligence were to arise during that time, it would make sense for it to come from the dominant group, and if it did, its legacy might live on not in ruins, but in the behaviours of their descendants, the birds that still surprise us with their problem-solving and adaptability. Even without a civilization, the age of reptiles shows us that intelligence can arise in unexpected ways, in forms very different from our own. It's a reminder that the capacity for complex thought isn't tied to any one body plan or ecological role. It depends on opportunity, on the right combination of traits, and on the time to let those traits develop into something more. The thought of an intelligent, culture-building dinosaur lineage invites us to expand our imagination beyond the familiar. It asks us to consider what kinds of civilizations might develop under conditions we've never experienced, with bodies and senses unlike ours, in environments that no longer exist. It also leads naturally to another possibility, one that doesn't involve land at all, but the vast and largely hidden world beneath the waves. If the land is a restless and forgetful place, constantly shifting and erasing itself, the oceans are an even deeper mystery. They cover most of the planet, hide its tallest mountains and deepest valleys, and hold within them ecosystems that are still largely unknown to us. For as much as we've mapped the continents and catalogued life on the surface, the sea remains a place of unanswered questions. We've explored only a small fraction of its depths in person, and much of what lives there never comes close enough to the surface for us to see. If there had ever been a civilization beneath the waves, its story might still be hidden in the places we've barely begun to look. It's an idea that feels almost inevitable once you consider the timescales involved. Life began in the oceans long before it found its way onto land. Complex multicellular organisms thrived there for hundreds of millions of years before the first forests appeared. Even after land-based ecosystems grew and flourished, the seas continued to support their own evolutionary experiments, some of them producing animals with remarkable intelligence. Today, dolphins, whales, and certain species of octopus show cognitive abilities that rival those of many land mammals. They solve problems, communicate in complex ways, use tools, and in some cases pass learned behaviours down through generations. If intelligence could develop to that level in multiple marine lineages in the relatively short time since humans evolved, it's worth asking what could have happened if one of those lineages had been given tens of millions of years more to work with. The oceans have been stable in some respects for vast periods, no glacier scouring them clean, no tectonic uplift exposing their floors to erosion. They change in currents and chemistry, but there's always somewhere in them for life to persist. For an intelligent aquatic species, this could mean an unbroken stretch of time to develop technologies and cultures suited to their environment. The challenge for us, trying to imagine such a civilization, is that our concept of technology is based on fire, metal, and stone, things that are difficult or impossible to use underwater. But technology doesn't have to look like ours. A marine civilization might work with the materials available to them: shells, coral, volcanic rock, plant fibers, or even carefully cultivated colonies of living organisms. They might shape the seafloor, building shelters in caves or trenches, creating gardens of seaweed and algae for food, raising shellfish in protected areas. Their art could be patterns made of coloured shells, arranged in ways only visible from certain angles, or intricate coral structures grown over decades. Their communication might be based on sound, light, or even chemical signals, travelling through the water far more efficiently than in air. Whales can communicate over vast distances with low-frequency sounds that carry across whole ocean basins. Bioluminescent organisms already use flashes of light to signal one another. An intelligent marine species could develop languages built from such systems, exchanging complex information without ever needing a written script in the sense we know it. The traces of such a civilization would be fragile. Organic materials decay quickly in the ocean, especially in warm, oxygen-rich waters. Coral and shell structures can last for centuries, but over millions of years they dissolve or are buried in sediment. Even the seafloor itself is young compared to the continents. As oceanic crust is created at mid-ocean ridges, it moves outward and is eventually subducted into the mantle, carrying anything built upon it down into heat and pressure that erases all record. The oldest ocean floor on Earth today is about 200 million years old, a blink in geological time. That means any ocean-based civilization older than that would have its home territory literally destroyed, recycled into new crust. But that doesn't mean all traces would vanish. Some could survive in coastal regions that were once under shallow seas, now lifted above the water by tectonic activity. We already find marine fossils in desert cliffs and mountain ranges, reminders of ancient oceans that no longer exist. If a marine civilization had built structures in such shallow zones, some fragments might still be there, buried under layers of sediment, waiting to be uncovered. Chemical evidence might be another clue. A large-scale alteration of the marine environment, whether through farming, construction or energy use, could leave traces in sediment chemistry. We've already seen how human activities leave such marks. Changes in nitrogen levels from fertilizer runoff, heavy metal deposits from mining and industry, microplastics accumulating in sediments around the world. Over time, most of these will be buried, but some could be preserved in deeper layers, telling future geologists that something once altered the oceans in a way that nature alone could not explain. There's also the possibility of fossilized remains of the species itself. Bones, shells, or other hard parts can survive if buried quickly in low-oxygen environments, such as deep-sea sediments or anoxic basins where decay is slowed. If an intelligent marine species had such durable body parts, a few might have fossilized. The difficulty is recognizing them for what they are. Without a modern analogue, their anatomy might not be understood as belonging to an intelligent tool-using being. They might simply be catalogued as an unusual extinct animal, their capabilities never suspected. Thinking about an ocean empire also changes our assumptions about what civilization might require. We tend to link the concept to land-based activities, agriculture, permanent settlements, monuments. But in the sea, resources are three-dimensional, spread out in a volume rather than across a surface. Mobility could be more important than permanence, and seasonal or migratory patterns might replace the fixed borders we associate with human civilizations. An aquatic culture might have no cities at all, instead gathering in temporary hubs during certain times of year, then dispersing to smaller groups. Their history could be carried entirely in memory, song, or genetic patterns of learned behavior, leaving almost nothing behind for us to find. It's also possible that an oceanic civilization might interact with land in some way, especially if it included amphibious species or individuals capable of limited time on shore. They could have harvested resources from beaches, cliffs, or tidal zones, perhaps even shaping the shoreline to suit their needs. Such interactions could leave more durable traces, stone arrangements, altered waterways, or shell middens much larger and more complex than those created by non-intelligent species. Over millions of years, these could be buried in coastal sediments, waiting for someone to recognize their significance. The oceans have always been places of both abundance and danger. Food can be plentiful, but so can predators. Storms, currents, and shifting temperatures can reshape entire regions. For an intelligent marine species, survival would mean learning not just the patterns of the sea, but how to anticipate and adapt to its changes. That knowledge, passed through generations, could become a foundation for culture. And just as we see with whales and dolphins today, the social bonds in such a species could be deep and lasting, with individuals cooperating, teaching, and caring for one another in ways that go far beyond instinct. If such a civilization had existed, its disappearance might be even harder to detect than one on land. The very environment that sustained it would also conceal its passing. Storms would dismantle their works, currents would scatter them, geological processes would swallow their homes. All that might remain is a faint chemical anomaly in a layer of rock that once formed on the seabed, or a few scattered fossils that no one recognizes as anything more than another extinct marine species. And yet, the ocean is patient. It has hosted life since the beginning, and will likely do so long after the continents have shifted into shapes we wouldn't recognise. It has the capacity to nurture intelligence, as it has done more than once in our own era. If intelligence can rise again and again in the relatively short span we've been here, perhaps it has risen before in forms we can only guess at. Yes. From here, the path of speculation leads back to the land, to the other possible candidates for an early civilization. Creatures that might not have dominated the earth as visibly as dinosaurs, or filled its depths like marine empires, but that could have found their own way to complexity before we ever arrived. The creatures that dominate our imagination when we think about prehistory are often the ones that left the biggest bones or the most striking silhouettes. Dinosaurs, mammoths, saber-toothed cats. These are the headline names. But Earth's past wasn't only shaped by giants. Much of its story was written by smaller, less conspicuous animals, the ones that fill the spaces between the spectacular and the ordinary. And among those, it's possible there were species that reached levels of intelligence and cooperation that never made it into our fossil hall of fame. These are the ones we might call the forgotten builders. They may not have been the rulers of vast ecosystems or the apex predators of their time. Instead, they could have lived in tightly knit groups, perhaps in sheltered environments where resources were predictable and safe enough to allow for experimentation. Intelligence doesn't always evolve in the spotlight. Sometimes it grows quietly in the margins, in places where survival allows time for learning, teaching, and creating. Looking at life today, we can see that the seeds of civilization-like behaviour exist in more than just humans. Beavers alter rivers and landscapes to create ponds for their lodges. Certain birds build complex nests, weaving them from multiple materials in ways that show individuality and even regional styles. Some primates form intricate social hierarchies and pass down techniques for using tools. Ants and termites construct elaborate cities underground or in towering mounds above it, complete with ventilation systems and specialized chambers. None of these cross fully into what we would call civilization, but they hint at how environmental pressures and social behavior can create the conditions for something more. If we imagine a forgotten builder in the deep past, it might have combined several of these traits: an ability to manipulate the environment, a capacity for problem solving, and a culture of passing knowledge from one generation to the next. Such a species might not have needed to dominate every corner of the globe. It could have thrived in a limited range, adapting its surroundings to suit its needs in ways that left little trace millions of years later. The physical form of these hypothetical builders could have been almost anything. They might have been small mammals with nimble paws, capable of shaping materials with precision. They could have been large birds with strong beaks and feet, able to transport and arrange objects. They might even have been reptiles or amphibians with dexterous limbs, working in damp or forested environments. The common thread would have been an ability to use their bodies to change their surroundings intentionally and repeatedly. What they built might not resemble our architecture. It could have been made entirely of organic materials, woven shelters from plant fibres, dugout chambers reinforced with clay, or raised platforms from interlocking branches. These wouldn't have lasted long once abandoned, especially in wet climates where rot and insects work quickly. Over millions of years, even the soil patterns they left behind could be erased by erosion, flooding, and the slow churn of geological processes. The challenge in finding traces of such a species is the same as with any ancient civilization. Most of what we might look for would be gone. We would have to search for indirect signs. If their building practices altered the flow of water, we might find unusual sediment patterns or layers rich in certain minerals. If they cultivated plants, the fossil pollen record might show a sudden and localized abundance of a species far outside its normal range. If they hunted or gathered in particular ways, there might be distinctive patterns of animal remains in ancient deposits. But even these signs can be ambiguous. Nature is full of processes that mimic the effects of intelligent activity. Rivers shift course naturally, carrying minerals into new areas. Wind and animals can spread plant seeds far from their original habitats. Predator kills can accumulate in spots that mimic the refuse piles of a hunting society. Separating the deliberate from the accidental is one of the hardest tasks in archaeology, and the further back in time we go, the more difficult it becomes. There's also the matter of how we interpret intelligence. We measure it largely in human terms, valuing abilities that resemble our own. We see language, symbolic art, and complex tools as high markers, but there may be other expressions of intelligence that don't leave behind obvious artifacts. A forgotten builder species might have developed elaborate oral traditions, memory-based mapping of landscapes, or seasonal gatherings to share knowledge, forms of culture that vanish completely once the species is gone. Their greatest achievements could have been entirely ephemeral, surviving only in the minds of their members and lost forever with them. It's possible that some lineages we now see only as ordinary animals were once capable of more than we realize. Evolution is not a steady climb toward greater complexity. It's a branching, shifting process where traits appear, disappear, and sometimes reappear in different forms. A species can develop high intelligence and then lose it if it no longer provides an advantage. If such a thing happened in the past, the traces might be so faint that we wouldn't even know where to start looking. We also have to consider that these forgotten builders might have lived alongside other intelligent species, perhaps even competing with them. The fossil record shows many times when multiple large-brained animals coexisted, particularly among mammals. If one species was more adaptable or better suited to changes in climate and resources, it might have replaced another before the latter had time to leave a significant mark. In that case, the builders could have been erased not just by geological forces, but by the success of their rivals. In our own time, we've seen how quickly cultures can vanish when faced with competition, environmental change, or disease. Entire languages have been lost in a single generation. Knowledge built up over centuries can disappear when the people who carry it are displaced or destroyed. Scale that up to millions of years, and it's easy to see how an entire civilization, especially a small or localized one, could vanish without leaving more than a whisper in the geological record. If such builders existed, they might have been remarkably adaptable in their own way, finding solutions suited to their environment rather than following the technological path we know. They might have domesticated animals we've never heard of, cultivated plants that are now extinct, or shaped landscapes in ways we no longer recognize. In their time, they could have been as successful and innovative as we are today, even if the form of their civilization looked nothing like ours. The thought of these forgotten builders invites a kind of humility. It reminds us that the history of life is far bigger than the human story, and that intelligence and culture may have bloomed in many forms before us. The world we know is not the only world that has ever been possible, and the ways of life we take for granted are just one branch of a much larger tree. Speculating about them also pushes us to think differently about how we search for the past. Instead of only looking for stone monuments or metal tools, we might also look for subtler patterns, changes in soil chemistry, unusual concentrations of certain plants or animals, or geological features that don't quite fit the local natural processes. We might train ourselves to see the possibility of deliberate design in places where we'd otherwise see only chance. And if we accept that such a species could have existed on land without leaving obvious ruins, it becomes easier to imagine that similar stories might have played out in other environments, on mountain slopes, in desert oases, in places where the landscape itself was their greatest tool. Which naturally leads us toward considering not just the materials they might have used, but the science of detecting traces so faint that they can barely be distinguished from the background noise of the Earth's own history. When you think about the physical remains of the past, it's easy to picture the obvious ones: bones in a museum display, stone tools in a glass case, fragments of pottery with their painted patterns still visible. But the truth is, most of the history of life isn't preserved in objects like these. It's written in the smallest of details, buried deep in the layers of the earth, where the sediment itself is the archive. Every grain of sand, every particle of silt, Every layer of clay is a page in a book that took millions of years to write. And just like any book, some pages are faded, some are smudged, and some are missing altogether. Sediment is everywhere. It forms in rivers and lakes, on the sea floor, in deserts, and at the base of mountains. It's made from the broken down pieces of older rocks, the remains of plants and animals, the dust carried by wind or washed by rain. Over time, layer after layer builds up, burying whatever falls into it. If conditions are right, if the material is quickly covered and protected from disturbance, those layers can last for millions of years, holding on to the tiniest clues about the world that created them. To the trained eye, these layers can tell stories. A coarse, gravelly deposit might mean a fast-flowing river once cut through the area. Fine, uniform silt could point to a calm lake or a slow-moving part of the sea. Alternating light and dark bands might reflect seasonal changes like the annual rings of a tree. Even without a single fossil, sediment can reveal whether the climate was warm or cold, wet or dry, stable or chaotic. And sometimes the sediment carries more than just a general impression. It can hold microscopic remains, tiny shells from plankton, grains of pollen from ancient forests, or spores from long-vanished ferns. These particles are incredibly durable, and they can tell us which plants and animals were present when the layer was laid down. A sudden spike in one type of pollen might suggest that a plant became unusually common in that region. A sharp drop could mean it disappeared, perhaps due to a shift in climate, a natural disaster, or the arrival of something new that changed the balance of the ecosystem. For anyone searching for signs of a lost civilization, this is where the trail often leads, not to grand ruins or intact artifacts, but as subtle, layered changes in the environment that could hint at human-like influence. We know from our own history that agriculture, deforestation, mining and pollution all leave measurable marks in sediments. Large-scale farming changes the mix of pollen in the soil. Metalworking can leave traces of lead, copper or mercury that persist long after the smelters have cooled. Even our modern plastic waste is settling into sediments around the globe, forming a future geological layer that will be unmistakable to whoever or whatever studies it millions of years from now. The problem, of course, is that natural processes can create many of the same signals. Volcanic eruptions can spread heavy metals far and wide. Droughts can wipe out certain plants and give others room to spread. Shifts in ocean currents can change the chemistry of sediments over huge areas. A layer of dark material rich in carbon might point to widespread burning, but whether that burning was the result of a lightning-sparked wildfire or intentional land clearing by an intelligent species isn't easy to determine. This is why scientists who work with sediments often approach them the way detectives approach a crime scene. One piece of evidence isn't enough. You look for patterns, for multiple clues that point in the same direction. If a layer of sediment shows an unusual chemical signature, you ask, is there a matching change in pollen? Are there signs of soil disturbance consistent with farming or construction? Do fossilized remains of animals show a sudden shift in diet or habitat that would make sense if humans, or human-like beings, were altering the landscape? Even when patterns do emerge, certainty is rare. The further back in time you look, the more the details blur. A single layer of sediment might have taken centuries to form, mixing together events that happened years apart. Over millions of years, pressure and chemical changes can alter the composition of the material, erasing or distorting the original signals. And because sediments are constantly being moved and redeposited, a single discovery might have travelled far from where it originally formed. Still, the potential is there. If an ancient civilization had engaged in activities like large-scale farming, metallurgy, or energy production, some trace might survive in sediments, particularly in areas that were geologically stable for long periods. The key would be finding those stable regions and reading their layers with enough precision to distinguish the extraordinary from the ordinary. In our own time, we've already seen how dramatically human activity can reshape sediments. In places near industrial centres, layers laid down over just the past 100 years are full of chemical markers, Everything from leaded gasoline residues to radioactive isotopes from nuclear testing. Far from cities, in remote lakes and polar ice, the sediments still carry the fingerprints of human industry, borne on winds and currents that reach even the most isolated places. These are changes so widespread that they will be visible in the geological record for tens of millions of years. If we can leave such a strong mark in such a short time, it raises the question, what would the equivalent layer from a past civilization look like? If they were industrial, the sediment might carry traces of their energy sources, whether that was burning biomass, smelting metals, or something entirely unfamiliar to us. If they altered landscapes for agriculture, the pollen record might show sudden, lasting changes in plant composition. If they lived primarily along coasts or rivers, the sediments in those regions might carry the densest concentration of clues. There's also the intriguing possibility that a past civilization might have used materials we don't recognize as artificial. Our own sediments now contain synthetic compounds, plastics for example, that did not exist in nature before we made them. Millions of years from now, these might survive as distinctive microscopic particles, even if they no longer resemble the original objects. A non-human civilization could have developed its own unique materials, which might now appear to us as unusual but natural mineral inclusions. Without knowing what to look for, we could easily overlook them. Reading sediments for signs of the past requires patience and caution. Each core sample, each exposed cliff face, is a puzzle with missing pieces. The challenge is not only to gather as many clues as possible, but to ask the right questions about what they mean. Are we seeing the effects of climate, geology, biology, or something else entirely? Are we looking at a moment of change in the natural world, or the legacy of intelligent action? The deeper you go into the sediments, the more you realize how much they hold, and how much they hide. They are both witness and participant in the planet's story, recording what happens even as they are shaped by it. If a past civilization left its mark here, it would be like a ghost in the record, faint, partial, and easily mistaken for something else. Finding it would require not only technical skill, but the willingness to see intelligence where we're accustomed to seeing only nature. And if such a ghost were ever recognized for what it was, it would force us to rethink everything about our place in the planet's history. We would no longer see ourselves as the first to alter the Earth in a lasting way, but as just one in a line of builders, separated by spans of time so great that only the sediments remember. Which leads to another line of investigation, one that doesn't focus on the physical shape of past life, but on the chemical signatures they might have left behind, hidden in the very fabric of the Earth's oldest materials. If you think about it, everything we do leaves a chemical trail. Every fire produces smoke rich in particular compounds. Every factory releases byproducts into the air, the soil, or the water. Every mine shifts the balance of minerals in the ground. These traces don't just vanish. They move through the environment, settle into sediments, and sometimes lock themselves into the geology for spans of time far beyond human history. Even natural processes, volcanoes erupting, rivers flooding, glaciers grinding, leave behind their own distinct chemical signatures. The Earth is layered with these markers, each telling part of the story of what happened and when. That's why scientists looking for signs of a long-lost civilization often think about chemistry as much as about fossils or artifacts. A chemical signature can survive where physical structures are destroyed. It can travel farther than bones or tools. It can outlast even the species that made it, sitting quietly in a rock layer until someone comes along to measure it. The trick is knowing what counts as unusual, what kind of pattern is unlikely to be the result of purely natural forces. We've already created such patterns ourselves. The Industrial Revolution left measurable spikes in certain heavy metals, like lead, copper and zinc, in soils and sediments across the globe. The mid-20th century left an even more striking layer, the fallout from nuclear testing which scattered radioactive isotopes into the environment worldwide. These isotopes have half-lives of thousands to millions of years, meaning they will remain detectable for far longer than our buildings, or even many of our fossilized bones. Future scientists, whether human or something else entirely, will have no trouble identifying the layer that marks our time. But suppose you were to go looking for an older version of such a chemical anomaly. You wouldn't expect to find the exact same pattern. A different civilization might have used energy sources we never considered, or processed materials we've never touched. Instead, you'd be looking for deviations, combinations of elements or isotopes that are rare in nature, but common in certain industrial or technological activities. You'd also have to rule out natural events that could produce similar results, like volcanic eruptions or meteor impacts. Volcanoes, for example, can release large amounts of sulfur, mercury, and other elements into the environment. But volcanic deposits tend to have specific ratios of these elements, and they are often concentrated near the eruption site. A civilization's emissions, on the other hand, might be spread across vast distances, carried by winds and water currents, showing up in multiple unconnected places at the same time. Similarly, meteor impacts can scatter rare metals like iridium, but they also leave unmistakable physical evidence, like shocked quartz or a crater, that can distinguish them from other sources. Another possible chemical fingerprint is the large-scale alteration of carbon isotopes. Plants, animals, and fossil fuels all have characteristic ratios of the lighter and heavier forms of carbon. When humans burn fossil fuels, we change the balance of these isotopes in the atmosphere and oceans, a shift that is recorded in tree rings, ice cores, and marine sediments. If a previous civilization had burned large quantities of fossil carbon, whether coal, oil, or some other form, the isotopic record might show a similar pattern. The difference would be in timing, depth, and context. A spike in carbon isotopes without evidence of a natural cause like massive volcanic activity could be a hint that something unusual happened. Mining can also leave a distinct mark. Extracting metals from ore often concentrates certain elements in waste piles or tailings. Over time, these can leach into the soil and water, creating localized chemical anomalies. If those anomalies are preserved in sedimentary layers, they might survive for millions of years. An unusually high concentration of a metal that's rare in the surrounding rock could be one of the clearest signs of deliberate extraction. The challenge is finding these anomalies in the first place. They might be buried deep beneath newer layers, or hidden in regions that haven't been studied in detail. It's also worth thinking about what kinds of materials an earlier civilization might have created that nature does not. We've made plastics, synthetic rubbers, and a variety of polymers that simply didn't exist before. Many of these materials are resistant to decay, at least on human timescales, and they tend to break down into tiny particles rather than disappearing completely. Over millions of years they might undergo chemical changes, but their basic composition could still be recognizable as artificial. If a previous civilization had its own equivalent, synthetic compounds unlike anything found in nature, those could serve as unmistakable markers, provided they survived in a recognizable form. One of the fascinating things about chemical fingerprints is that they often overlap with other kinds of evidence. A shift in pollen types in a sediment core might coincide with a rise in certain metals, suggesting land clearing and mining happened at the same time. A spike in carbon isotopes might align with layers rich in ash, pointing to widespread burning. These kinds of correlations make the case stronger because they suggest multiple connected activities rather than unrelated natural events. Of course, the absence of such evidence doesn't prove that no civilization existed. A culture that lived in balance with its environment, relying on renewable resources and avoiding large-scale extraction or combustion, might leave almost no detectable chemical trace. Its legacy could vanish into the background noise of natural variation, indistinguishable from the baseline patterns of the planet. In a way, this is what makes the search both difficult and intriguing. We're looking for signs that could be as glaring as a neon light or as subtle as a faint smudge in the data. To make matters more complicated, the chemical record is not evenly preserved. Some environments are excellent at locking in chemical signatures, Deep ocean sediments, lake bottoms, and ice cores can preserve stable records for hundreds of thousands or millions of years. Others are constantly disturbed, erasing the evidence almost as quickly as it's created. Floodplains, shorelines, and shallow soils are in constant motion, mixing old material with new. A civilization that lived primarily in these dynamic zones might leave few lasting chemical traces, even if it was technologically advanced. And then there's the issue of recognition. Even if we find a chemical anomaly, we have to be able to tell whether it's significant. We have to compare it against the broader context of the planet's history. Is it unique to one place and time, or does it recur in multiple eras? Does it fit with what we know about natural cycles, or does it stand apart in a way that begs for another explanation? In many cases, we might already have stumbled across anomalies that don't fit neatly into the known patterns, but without the right framework, we may have filed them away as curiosities rather than evidence of something extraordinary. If a lost civilization left its mark in this way, it could be hiding in plain sight, in samples already collected, in cores stored in laboratories, in data archived for decades. The challenge is to look again, to ask new questions of old evidence, and to be open to interpretations we might once have dismissed. The chemical record is vast, and our ability to read it is still growing. New analytical techniques can detect elements and compounds in parts per trillion, revealing subtleties that would have been invisible a generation ago. With every improvement, the odds increase that we might notice a pattern that doesn't belong to the natural rhythm of the planet. But chemical traces, no matter how compelling, are still only part of the story. To make the case for an ancient civilization, we'd want to combine them with other lines of evidence, patterns in sediment layers, changes in fossil distribution, shifts in climate data, that together form a picture too consistent to ignore. And that search inevitably leads us to the few serious scientific attempts to grapple with this very possibility, the most notable of which has come to be known as the Silurian hypothesis. When scientists speak about the Silurian hypothesis, they're not claiming that such a civilization definitely existed. It's not a declaration, but an exercise in thinking. The idea was put forward as a way of asking, if there had been an intelligent industrial society on Earth millions of years before humans, would we be able to find any evidence of it today? And if so, what would that evidence look like? The name itself comes from science fiction. In the 1970s, a British television show introduced a fictional species called the Silurians, intelligent reptilian beings said to have evolved on Earth long before humans appeared. The scientists who coined the term weren't suggesting that the TV backstory was true. They were borrowing the name as a light-hearted reference for a serious question. They chose the Silurian hypothesis not because they thought such a civilization arose in the actual Silurian period hundreds of millions of years ago, but because it captures the central idea, looking for traces of something intelligent that came long before us. The authors of the original paper, Gavin Schmidt and Adam Frank, weren't paleontologists digging for fossils. Schmidt is a climate scientist, and Frank is an astrophysicist. They came at the question from the perspective of planetary science, how civilizations, including hypothetical alien ones, might leave lasting marks on their worlds, and how those marks might be detected. Their work wasn't just about Earth's history, but about building a framework that could also apply to other planets we might someday study. If Mars, for instance, had ever supported intelligent life, what signs could we expect to find now? They began by noting that human industrial activity has already changed the planet in ways that will persist for millions of years. We've altered the composition of the atmosphere, shifted the balance of carbon isotopes, spread synthetic compounds, and left chemical residues from mining and manufacturing. These changes will be recorded in sediments, ice cores, and rock layers, creating a distinct geological boundary marking the Anthropocene, the proposed name for our current epoch. If an earlier civilization had gone through its own version of industrialization, Schmidt and Frank reasoned, similar changes might be visible in the deep geological record. But they also pointed out the challenges. Over tens of millions of years, the surface of the Earth is constantly recycled. Erosion, subduction, and the slow churning of the crust erase most evidence. Structures decay, metals corrode, even stable compounds eventually break down. The older the civilization, the less likely its direct artifacts would survive. This is why their focus turned to indirect evidence, especially chemical and isotopic signals. Industrial activity tends to produce combinations and concentrations of elements that don't occur naturally, or at least not in the same patterns. Large-scale agriculture can change the distribution of plant species and alter soils in ways that persist. Fossil fuel use can shift carbon isotope ratios in a way that is hard to mimic with purely natural processes. These are the kinds of markers that might outlast the civilization itself, buried in rock layers long after its cities have crumbled. The hypothesis also forces us to confront our assumptions about what counts as civilization. We imagine cities, roads, and monuments, but those are products of our biology and environment. A non-human civilization might have taken a very different form, one that left far fewer durable traces. If it relied on organic materials, renewable energy, and decentralized settlements, its signature in the geological record might be faint. If it existed in a geologically unstable region, even that faint signal could be erased entirely. To test the idea, Schmidt and Frank looked for examples of abrupt changes in the geological record, spikes in certain elements, shifts in isotope ratios, unexplained climate events that might have parallels with modern human impacts. Some of these changes could be explained by natural causes, like volcanic eruptions or asteroid impacts. Others remain less certain, but even the unexplained ones don't provide proof. They're simply anomalies, the meaning of which is open to interpretation. One of the points they stressed was that our own history could serve as a warning. If our civilization were to vanish tomorrow, the traces we've left would be clear for a time, but they would not last forever. After a few million years, almost all of our physical structures would be gone. Only the chemical and isotopic changes would remain, and even those would fade with enough time. The deeper the burial, the greater the chance that heat and pressure would erase the signal entirely. This perspective changes how you think about the search for ancient civilizations. It shifts the focus from looking for physical ruins to reading the planet's chemistry. It also expands the timeline. Instead of restricting our imagination to the last few thousand or million years, we can consider the possibility that civilization-like activity could have occurred hundreds of millions of years ago, in an era when the continents were arranged differently, the climate was unfamiliar, and the dominant species were unlike anything alive today. The Silurian hypothesis doesn't claim that such a civilization existed. It's more about mapping out the limits of what we could know. It acknowledges that the absence of evidence is not evidence of absence, but it also sets boundaries. There are kinds of evidence we might expect to survive, and if we don't find them, that tells us something about the likelihood of certain scenarios. It's a way of turning a speculative question into something testable, even if the test is difficult. And it's not just about the past. The same principles apply when we think about the future of our own species. If we survive for another million years, how will our signature in the rock record compare to what we've already created? If we vanish sooner, how quickly will the planet erase our traces? And if we look to other planets and moons for signs of life, will we recognize the signals of civilizations that might be very different from our own? The Silurian hypothesis is, in a way, a mirror. It asks us to look at our own impact on Earth and imagine it from the perspective of someone or something studying it millions of years from now. It reminds us that we are not the first living things to shape this planet, and perhaps not the first to do so in ways that could be called civilization. It also reminds us that time is a powerful eraser, one that can smooth away even the sharpest lines, leaving only the faintest echoes for the curious to find. And if there's even a chance that echoes from a forgotten civilization are still out there, waiting to be recognized, then the question naturally follows: if they had language, if they had culture, if they spoke to one another across the ages, would we even be able to understand them now? When we talk about communication in the context of a lost civilization, it's easy to picture something we recognize, written symbols on a surface, sounds formed into words, gestures with shared meaning. That's how we define language because it's how we use it. But the truth is, language is simply a structured way of transmitting information, and it can take forms that don't resemble anything humans have ever made. If there was a civilization before us, it's entirely possible their system of communication would be so unlike ours that even if we stumbled across a record of it, we wouldn't recognize it as language at all. Language is shaped by biology. The way humans speak is determined by our vocal apparatus, lungs pushing air, vocal cords vibrating, tongues and lips shaping the sound. Our hearing range influences the frequencies we use, and our eyesight helps us understand written forms and body language. A non-human civilization could have been built by creatures with entirely different sensory ranges and anatomical structures. If they relied on frequencies too high or too low for us to hear, we might never detect their spoken exchanges without specialized equipment. If their visual communication used colors outside the human range of perception, any remnants could appear meaningless to us. Even within our own world, we see a wide variety of communication strategies. Dolphins use bursts of sound that vary in pitch, duration, and pattern, possibly encoding complex messages. Cephalopods like octopuses and cuttlefish change the color and texture of their skin in rapid, intricate patterns that could convey information instantly to others of their kind. Bees perform dances to tell hive mates the direction and distance of food sources. Ants use chemical trails, laying down pheromones that other ants can read. Each of these systems is adapted to the abilities and needs of the species using it. If we were to encounter the remnants of such systems without the living creatures to demonstrate them, our ability to interpret them would be limited. Imagine finding a fossilized octopus with no understanding of how it once communicated through color changes. You could study the structure of the skin, even reconstruct the pigments, but without seeing the behavior in action, the meaning would remain locked away. The same would apply to the traces of a vanished civilization. Without knowing the sensory world they lived in, the physical form of their language might be incomprehensible. Writing, as we think of it, poses its own challenges. We tend to look for repeated shapes, consistent spacing, and recognizable sequences as signs of symbolic language. But these are shaped by our own needs and tools. An alien writing system might not be linear. It could be multi-dimensional, combining spatial arrangement, texture, and even chemical properties. It might be designed to be read only under certain conditions, immersed in water, viewed in ultraviolet light, or touched to feel microscale patterns. Without the right perspective, such writing might appear to be nothing more than random markings, mineral deposits, or biological growths. Even if we did recognize something as a form of symbolic communication, translating it would be a monumental challenge. The breakthrough with ancient human scripts often comes from finding a Rosetta Stone, a text that says the same thing in multiple languages, at least one of which we understand. Without such a key, translation can take decades, even for related human languages. For a non-human language, the gap could be far greater. Concepts that were central to their culture might have no equivalent in ours. Words might be based on sensory experiences we cannot have, or on social structures that are entirely foreign to us. It's possible, too, that they might not have used discrete words in the way we do. Some modern animal communication seems to rely on continuous variation rather than distinct symbols, a sliding scale of sound, colour or chemical concentration that conveys meaning through subtle shifts. Translating such a system would require not just recognizing its existence, but understanding the context in which it was used. Without that context, we could easily mistake it for background noise. One of the more humbling aspects of this idea is that we might already have encountered the remnants of a non-human language and failed to recognize it. Patterns in ancient rock formations, arrangements of shells or stones, or recurring chemical anomalies could be dismissed as natural because we lack the framework to see them as deliberate. We might be looking right at the equivalent of a sentence or a story, and it would mean nothing to us. On the other hand, if we did recognize a pattern that seemed deliberate, the next step, understanding, would be another leap. Deciphering meaning requires connecting symbols to real-world references, something that's possible only if we can make educated guesses about the subject matter. With human languages, we often start with proper names, numbers, or descriptions of familiar events. For a vanished non-human civilization, those reference points might not exist. The names in their records could be of places or species long extinct. Their accounts of natural events could describe climates or landscapes that have no modern equivalent. And then there's the possibility that their communication system wasn't meant to be permanent at all. Humans record information in durable media, stone, clay, metal, digital storage, precisely because we want it to last. But another species might have valued impermanence, using signals that were meant to fade quickly, existing only in the moment of their exchange. A language of sense, for instance, would linger for hours or days at most, vanishing without a trace. In that case, the only evidence of their communication might be found indirectly, in the biological adaptations that allowed them to produce and detect those signals. Even if we never decode their words, the existence of a language would tell us something profound, that they had the cognitive capacity to share abstract ideas, to coordinate, to plan for the future, and to reflect on the past. Language is one of the strongest indicators of intelligence, because it allows for the transmission of complex information across time and generations. It's a way of storing thoughts outside the mind, whether in symbols, performances, or shared memories. If a pre-human civilization had such a system, it would have shaped every part of their society, how they hunted or gathered food, how they formed social bonds, how they passed down knowledge. It might even have influenced the evolution of their brains and bodies, selecting for individuals who could produce and interpret the language effectively. That influence could leave traces in the fossil record in the form of specialized sensory organs or brain structures, though recognizing those features would still require knowing what to look for. Considering all this, the question of whether we could understand them becomes even more complex. It's not just a matter of translating words, but of bridging an entire sensory and cultural gap. We would have to reconstruct not only their language, but the world it described. And that might be the most challenging task of all, because the deeper into the past we go, the more alien that world becomes. Still, if we imagine such a civilization, it's hard not to also imagine that they had some form of art, of storytelling, of cultural expression beyond pure survival. And if they did, then somewhere, perhaps buried or altered beyond easy recognition, there might be remnants of a creative life we've never suspected. Art, as we understand it, is one of the clearest reflections of a mind capable of imagination. It's a way of taking something internal, an image, a story, a feeling, and placing it into the world so others can share in it. We tend to think of it as uniquely human, yet even in our own time there are hints that other species create for reasons that go beyond immediate survival. Bowerbirds build elaborate structures decorated with brightly coloured objects, arranged with a sense of symmetry and pattern. Whales sing complex, evolving songs that don't appear to serve a purely practical purpose. Primates sometimes make marks or arrange objects seemingly without direct utility. These behaviours suggest that the impulse to create, to make something aesthetically pleasing or expressive, may not belong to us alone. If there was a civilization before ours, it's not far-fetched to imagine that they had their own forms of art, expressions that served no direct role in feeding them or sheltering them, but which enriched their lives in ways we might recognise. The challenge is that most art is fragile. Paint fades, wood rots, fabrics disintegrate. Even stone carvings can be worn down by weather or buried under shifting sediments. Over millions of years, the vast majority of human art would vanish without a trace, and it's likely the same would be true for any earlier civilization. What remains of ancient human art owes its survival to exceptional circumstances. Caves that shield paintings from the elements, arid deserts that preserve carvings, volcanic ash that entombs entire cities. If an earlier civilization created their art in places less protected, the odds of it surviving are vanishingly small. Even the choice of materials would matter. If they used organic dyes or pigments made from plants and minerals that break down quickly, nothing visible would remain. If they favoured performance over permanence, music, dance, or ephemeral installations, then their art would have been gone the moment it was experienced. That doesn't mean it would be entirely invisible to us now. Some artistic activities can leave indirect evidence. The pigments used for painting might survive as traces of unusual minerals in soil layers. Sculpture or ornamentation carved into durable stone could endure if it was buried deeply enough or sheltered in stable rock formations. Jewellery or decorative objects made from resistant materials like certain stones, shells, or metals might outlast their makers, though they could easily be mistaken for natural formations or simple tools if their purpose wasn't clear. There's also the question of whether their art would even be recognisable to us as such. Art is deeply tied to the sensory and cultural world of its creator. What one species finds beautiful might mean nothing to another. Colours we see as vibrant could be invisible to them, while patterns they found striking might be imperceptible to our eyes. Their sense of rhythm could be based on tempos we can't comfortably hear or reproduce. An arrangement of objects that held deep symbolic meaning for them might look random to us. Without understanding the cultural context, we could walk past their masterpieces without realizing what they were. It's worth remembering that even among humans, art from distant cultures or time periods can be difficult to interpret. Ancient geometric carvings, abstract designs, and symbolic motifs can puzzle archaeologists for decades. We may know they were intentional and important, but their exact meaning remains speculative. Multiply that challenge by an entirely different evolutionary history, and you can see how easily the meaning of non-human art could be lost forever. There's also the possibility that their artistic traditions were tied to environments we rarely explore in the archaeological record. If they lived primarily in coastal regions, much of their art could now be underwater due to changes in sea level. If they inhabited forests, their works might have been quickly reclaimed by vegetation and decay. If they lived underground or in caves, their art might still exist in hidden chambers we've never accessed. But finding it would require knowing exactly where to look, and considering what such art might have been, it helps to think beyond our own categories of painting, sculpture, and music. Their creations might have involved living materials, plants grown into deliberate shapes, bioluminescent organisms arranged into glowing patterns, seasonal displays made from migrating animals or blooming flowers. They might have worked with sound in ways we can't easily replicate, using frequencies or resonances that don't carry well in our air but were perfect in theirs. They might have created tactile art meant to be felt rather than seen, or scents designed to evoke memory and emotion. If any of these left a physical trace, it might be subtle. Altered growth patterns in fossilized plants, unusual arrangements of shells or stones in ancient sediments, microscopic wear patterns on tools used for carving or shaping. Without the knowledge that these were created for aesthetic rather than practical purposes, we might simply catalogue them as anomalies. The impulse to create also intersects with the impulse to record. If they had stories, histories, or myths, art could have been one of the ways they preserved and transmitted them. A sculpture might have embodied a cultural hero or a creation myth. A series of patterns might have encoded astronomical observations or seasonal cycles. An arrangement of objects might have marked a significant event or served as a memorial. Even if we couldn't decode these meanings, the act of creating them would point to a mind concerned with more than immediate needs. In the absence of witnesses, their art becomes not just a personal or cultural expression, but a potential message across time. Whether they intended it that way or not, it's one of the few things that could have had the power to survive them. The fact that we haven't yet found such a message doesn't mean it isn't out there. It might simply mean we don't yet recognize it for what it is. The Earth is vast, and our exploration of its oldest layers is still in its infancy. When we look at our own species, we can see how art shapes identity and community. It's possible that for them too, the act of creation reinforced social bonds, inspired cooperation, and provided a sense of continuity between generations. Even if their art never reached beyond their immediate surroundings, it would have been a defining part of who they were. The tragedy, if you can call it that, is that without someone to witness and understand it, that part of their identity would vanish as completely as the art itself. And yet, the absence of surviving works doesn't erase the likelihood that they existed. Just as we infer the presence of ancient languages from the complexity of a society's tools or social structures, we might one day infer the existence of non-human art from other signs, a level of cultural sophistication that all but demands an aesthetic dimension. But to get there, we first have to consider how such a society might have risen, how it might have flourished, and ultimately how it might have fallen. The story of any civilization, whether real or imagined, is a story of change. It begins with the conditions that allow it to form, it develops through the forces that help it grow, and it ends, or transforms, when those conditions shift beyond what it can adapt to. This pattern is not unique to humans. It's written into the history of countless societies across our own world, and it's reasonable to think that if another civilization existed long before ours, it might have followed a similar arc. To rise, a civilization needs more than just intelligence. It needs a stable enough environment to support growth. It needs access to resources, food, materials, energy, and a way to manage them efficiently. It needs cooperation among its members, which could be driven by social bonds, mutual benefit, or a shared sense of purpose. If our imagined pre-human civilization was ocean-based, they might have relied on stable currents, abundant fisheries, and predictable migration patterns of prey. If they were land-based, perhaps they developed in a region with fertile soil, moderate climate, and access to mineral-rich hills or forests full of useful plants. Once those foundations are in place, the next stage is specialization. Individuals or groups begin to take on different roles: food gatherers, toolmakers, builders, storytellers, navigators. Specialization allows efficiency and innovation because each role can evolve and improve over generations. This is the stage where traditions begin to form, not just traditions of culture and belief, but of technology and technique. The knowledge of how to build a certain kind of shelter, hunt in a specific way, or navigate by particular stars becomes part of the shared inheritance of the group. Growth also tends to bring complexity. As populations increase, more coordination is needed to distribute resources, resolve disputes, and maintain order. Leadership structures may emerge, whether formal or informal, centralized or distributed. This can be a moment of great creativity, when a society's values are codified into systems that shape its future. For a pre-human civilization, these systems might have been encoded in oral tradition, ritual, or symbolic art, or they could have been recorded in a medium we have yet to recognize as such. As their reach expanded, they might have spread into new environments, adapting their ways of life to different conditions. Coastal groups might have moved inland, river dwellers might have reached the open ocean, forest people might have learned to survive in open plains. This expansion could bring contact with other groups, whether of their own species or entirely different intelligent lineages. Cooperation could bring trade and exchange of ideas. Competition could bring conflict and innovation driven by necessity. But with growth comes vulnerability. The larger and more interconnected a civilization becomes, the more it relies on stable conditions. A changing climate, a shift in food sources, or a geological event could ripple through the entire system. For an ocean-based society, a change in water temperature or currents could devastate their primary resources. For a land-based one, Prolonged drought or flooding could collapse agriculture. These are pressures we can recognise because our own history is full of them. There's also the possibility of self-inflicted instability. Overexploitation of resources, environmental degradation, or internal conflict can undermine the very systems that allowed a society to flourish. Without careful management, a civilization can reach a tipping point where its demands exceed what its environment can provide. From there, decline can be swift or gradual, but it's often irreversible. If this hypothetical pre-human civilization had technology comparable to or beyond our own, the risks might have been even greater. Advanced tools can allow rapid expansion and exploitation, but they can also magnify the impact of mistakes. A poorly managed energy source, a destructive war, or an environmental catastrophe triggered by industrial activity could have had consequences far beyond their ability to repair. When decline sets in, it doesn't always mean a sudden collapse. Sometimes it's a slow contraction. Fewer settlements, reduced trade, loss of specialised skills. Traditions fade, infrastructure deteriorates, and knowledge once common becomes rare. In human history, we see examples of societies that shrank to a fraction of their former size, surviving in isolated pockets while the rest of their territory was reclaimed by nature. For a civilization millions of years in the past, the eventual disappearance of those last holdouts would erase the final living memory of what they had built. The fall might also have been triggered by events entirely outside their control. A large asteroid impact could have caused a global climate shift. Massive volcanic eruptions could have filled the air with ash and sulfur, cooling the planet and disrupting ecosystems. Tectonic movements could have submerged entire land masses or transformed coastlines beyond recognition. In such cases, even a well-managed civilization could have been overwhelmed. Whatever the cause, the end of a civilization marks the beginning of its transformation into history, and given enough time, into mystery. The physical traces begin to fade. Buildings crumble, tools corrode, art decays. Organic materials vanish quickly, while even the most durable structures are eventually buried, broken, or eroded away. In the deep timescales we're considering, the vast majority of their works would not survive. What remains might be scattered, fragmentary, and ambiguous. But even in its absence, the memory of their existence could echo in the world they left behind. Changes to ecosystems, genetic legacies in domesticated species, shifts in the distribution of certain minerals or chemicals. These could persist long after the civilization itself was gone. The echoes might be faint, but they would still be there for those who know how to listen. And if those echoes are faint now, it may be because they were buried under something even larger. For in the deep past, the Earth has experienced moments when life itself nearly vanished, when the slate was almost wiped clean, leaving only the survivors to carry on. If a civilization existed before us, it might have met its end in one of these cataclysmic events, disappearing not just from history, but from the very fabric of the biosphere. There's a strange kind of reflection that happens when we think about the deep past. We start with the idea that we're looking backward, studying the traces of what might have been. But at some point, without even realizing it, we find ourselves looking at our own world, our own moment in history, through the lens of what we imagine could have happened before. It's as though the ancient Earth is holding up a mirror, and in the faint hypothetical outlines of a long-vanished civilization, we see shadows of ourselves. In that mirror, the timelines stretch and fold in ways that make the present feel small. You imagine another species walking the Earth, or swimming in its oceans, or gliding through its skies millions of years before our ancestors were even a thought in evolution's mind. They had their own beginnings, their own periods of struggle and innovation, their own mastery of the environment. And maybe they also face the same kinds of challenges we do: resource limits, environmental shifts, internal conflicts, the gamble of technological change. It's easy to imagine that some of their debates, their fears and their hopes might have felt familiar to us, even if every detail of their culture was alien. This way of thinking is more than just idle curiosity. It's a way of breaking free from the illusion that our story is entirely unique. We often treat our current moment as the centre of history, as though intelligence and technology are rare miracles that have only just emerged. But if you allow yourself to picture others who came before, you have to face the possibility that civilizations are not one-time events. They could be recurring patterns in the life of a planet, rising and falling over millions of years, each one as confident in its permanence as we are now. That realization can be unsettling. It shrinks the ego a little, and it makes the future feel less certain. If someone else stood where we stand now, if they thought they had solved the puzzle of survival, and yet they are gone, then what does that say about our chances? It doesn't have to be a fatalistic thought. It can be a humbling one, a reminder that the survival of a civilization depends on more than intelligence or technology. It depends on balance, between growth and sustainability, between ambition and caution, between the needs of the present and the needs of the future. The mirror also works in the other direction, by thinking about how a past civilization might appear to us now, fragmented, incomplete, often indistinguishable from the background. We can better imagine how we might appear to whoever comes after us. What would they see in the geological record of our time? How much of what we think defines us would still be visible? And if our own signals are eventually reduced to a few strange layers of sediment and scattered chemical traces, would future minds be able to guess at the full complexity of our world? This thought exercise can shift how we view our current impacts. A layer rich in plastics, isotopes, and altered carbon ratios might someday be the most recognizable sign of our existence, even if our cities and cultures have long vanished. If that's the case, then our most enduring legacy might not be our art, our science, or our technology, but the footprint we've left in the physical planet itself. The same could have been true for the civilization we imagine in the past. Perhaps what survives of them is not their greatest achievement, but their most lasting alteration to the earth. Of course, a mirror can distort as much as it reflects. We project our own values and concerns onto this imagined past, shaping it into something that feels familiar enough for us to contemplate. It's possible that a pre-human civilization would have been so different from us in biology, psychology, and social structure that our comparisons barely make sense. Their concept of progress might have been entirely unlike ours. They might not have thought in terms of expansion, accumulation, or domination of nature. They might have measured success in cycles rather than lines, in balance rather than growth. If so, then their rise and fall might not follow the patterns we expect at all. Still, even if the details differ, the larger rhythm of emergence, flourishing, and decline could be universal. That rhythm is built into the nature of living systems, which thrive within certain conditions and falter when those conditions change too far or too fast. It's the same for forests, coral reefs, and civilizations, whether human or otherwise. The conditions for life are always shifting, and every adaptation is temporary. When you think of the deep past in this way, the boundaries between imagination and science blur. We don't have direct evidence of another civilization before ours, but we do have evidence of the forces that shape and erase civilizations. We know how landscapes change, how climate can turn from stable to volatile, how resources can be exhausted. We know how fragile our own systems can be when pushed too far. That knowledge doesn't prove there was someone before us, but it tells us that if there had been, their fate might have been determined by the same pressures that will one day test us. Looking into this mirror also reminds us that time itself is the ultimate editor. It cuts away most of the details, leaving only a few fragments for the future to interpret. In the case of our imagined predecessors, that editing has been brutal. Tens or hundreds of millions of years of erosion, subduction, chemical change, and biological recycling. If they were here, almost all traces are gone. The same will happen to us. The question is whether the fragments that remain will tell a story of survival, of adaptation, or of collapse. There's something strangely comforting about that perspective. It places us in a long continuum, not as a singular pinnacle of evolution, but as one expression among many. It doesn't diminish our achievements, but it does frame them as part of a larger, older pattern. And in doing so, it invites us to think more carefully about what we choose to leave behind, not just in terms of material impact, but in terms of the kind of world we create for those who might follow. If we could reach through that mirror and see the civilization we imagine, perhaps we would learn lessons they learned too late, or perhaps they would learn from us, watching to see whether we managed to navigate the challenges they could not. Either way, the reflection forces a question. If the pattern of rise and fall is written into the nature of civilizations, is there a way to step outside it? Or is the cycle as inevitable as the turning of the earth itself? And if it is inevitable, then perhaps the most lasting connection we could have with a civilization from deep time is not one of direct contact, but of shared experience. Two different societies separated by millions of years, both walking the narrow path between flourishing and fading, each unaware of the other, yet bound by the same rules of survival. When we talk about the possibility of other civilizations in Earth's deep past, the idea often feels like an isolated thought experiment. But the more you look at the rhythms of life over hundreds of millions of years, the more it starts to seem like a question about patterns rather than one-off events. Because if intelligence arose once in us, why should it have been the first and only time? And if it has happened more than once, what if there's a cycle to it? A repeating emergence of minds capable of shaping the planet in deliberate large-scale ways. Intelligence itself is not the same as civilization. The animal world is full of examples of creatures that demonstrate remarkable problem-solving skills, memory, and adaptability without ever building cities or industries. Octopuses can navigate mazes and use tools. Crows make hooks out of twigs to fish food from crevices. Elephants have complex social lives and seem to mourn their dead. None of these species has created a global infrastructure, but they show that intelligence in the raw sense is not rare. It evolves when it serves a purpose. Civilization, though, is something else. It's intelligence applied to long-term collective projects. It's the coordination of large groups toward shared goals, the development of technologies that compound over time, the ability to manipulate the environment far beyond what an individual could do alone. That combination, intelligence plus cooperation plus technology, is much rarer, at least in the fossil record we know. But rarity is not the same as impossibility. On Earth, complex life has been around for over 500 million years, and in that span there have been multiple bursts of evolutionary innovation. Whole new body plans appeared during the Cambrian explosion. Land plants transformed the atmosphere, vertebrates moved from water to land, and then, in some lineages, back to the water again. Flight evolved independently in insects, pterosaurs, birds, and bats. Each of these transformations happened not once, but multiple times, in different forms, and with different species. So why not civilization? It may be that given enough time, the combination of intelligence, cooperation, and technology emerges again and again, just as flight or vision does. The path might look different each time, shaped by the particular environment and evolutionary lineage, but the endpoint, a species capable of reorganizing the world around it, could be a recurring phenomenon. If that's the case, then what we're experiencing now is not unique in kind, only in detail. We might be the most recent in a series of civilizations that have risen, flourished, and vanished, each leaving behind traces that grow fainter with age. And if the traces of our own time will one day be difficult to recognize, how much harder would it be to detect those of a civilization that lived tens or hundreds of millions of years ago? It's not hard to imagine a cycle like this playing out over and over. A new form of intelligence emerges, adapting to the world it finds. It discovers ways to manipulate its environment to increase comfort, security, and resources. As it grows in numbers and capability, it develops tools and infrastructure, spreads across different habitats, and alters the planet on a scale large enough to be seen from space. For a time, it thrives. But eventually it encounters the same limits: environmental shifts, resource depletion, internal instability, or catastrophic external events. Some cycles might end quickly, in sudden collapses triggered by disasters too large to manage. Others might fade slowly, with populations dwindling and complexity unraveling over centuries or millennia. Either way, the outcome is the same: the civilization disappears, leaving the planet to recover and reset. After a long enough pause, the process begins again, with a different species, a different set of tools, and a different cultural path. One reason this idea is difficult to test is that the cycles could be separated by immense spans of time. Between one civilization and the next, tens of millions of years could pass, enough for the continents to shift, climates to change completely, and nearly all physical traces to vanish. Even if a few scattered artifacts survived, they might be buried so deeply, or altered so thoroughly, that they would be indistinguishable from natural features. It's also possible that not every cycle produces a technological civilization as we define it. Some intelligent species might choose paths that minimize large-scale environmental impact, valuing stability over growth. They might never develop metallurgy or industrial power, not because they lack the ability, but because their cultural priorities lay elsewhere. Such civilizations might still rise and fall, but their footprints in the geological record would be even fainter, perhaps invisible to any future observer. If cycles of intelligence do exist, they raise questions about what drives them. Is there something in the nature of evolution that makes advanced intelligence more likely over long periods of time? Or is it a rare convergence of accidents, a roll of the dice that doesn't come up often enough to form a true pattern? And if it is a pattern, does it follow a rhythm we could measure, tied to planetary cycles like climate shifts, tectonic reorganizations, or extinction events? Looking at Earth's history, we can see moments when such cycles could fit. After each mass extinction, life rebounds in bursts of diversity and innovation. These are moments when entirely new kinds of organisms take over ecological niches, sometimes developing novel capabilities. If intelligence is one of the possible outcomes, then the aftermath of an extinction could be fertile ground for it to evolve. In that sense, catastrophic loss might not just end civilizations, it might set the stage for the next one. This possibility reframes our own place in time. If we are part of a cycle, then our story is connected to others we will never meet. We are living in the space between what came before and what might come after. The traces we leave will be the starting point, or the cautionary tale for some distant future intelligence. Whether they recognize us or not, we will be part of their world in the same way a hypothetical pre-human civilization might still be part of ours through the changes they left embedded in the planet. It also raises the unsettling possibility that cycles don't necessarily lead to cumulative progress. Just because one civilization rises after another doesn't mean each is more advanced than the last. The conditions of the world at the time could favor different strengths, different priorities, and different technologies. The cycle could be less like a ladder and more like a wheel, turning endlessly through variations on the same themes. If that's true, then intelligence might be less of a linear march toward a pinnacle, and more of a recurring opportunity, one that can be seized or squandered, and which always comes with an expiration date. And in thinking about how such cycles might work, we can't avoid wondering what, if anything, survives between them. Could knowledge ever be passed from one to the next? Could traces of a past intelligence somehow influence the next to arise? Or does the slate always return to near blank, forcing each new civilization to start from scratch? The answer to that might determine whether cycles of intelligence ever lead to lasting change on a planetary scale, or whether they are simply passing waves in the longer ocean of Earth's history, leaving only faint ripples for those curious enough to notice. It's not a thought most people linger on for long, but imagining the world without us can be one of the most revealing exercises in understanding our place here. Not just in the abstract, but in concrete detail. What would happen if, for reasons natural or otherwise, our species ceased to exist overnight? The streets still full of cars, the lights still on in some places for a while, the skies still crossed by the faint lines of aircraft vapour. In that first day, the difference might not be visible from a distance, but the chain of events would begin immediately. Within hours, systems that depend on constant human oversight would begin to fail. Power grids would go down in sections as automated protections tripped without anyone to reset them. Some areas might hold on longer than others, thanks to backup generators or self-regulating infrastructure, but the overall decline would be steady. Nuclear power plants, without engineers to monitor them, would shut down as safety systems engaged, though the handling of spent fuel would pose hazards for decades to come. Satellites would continue to orbit for years, some for centuries, before atmospheric drag finally pulled them down. Within days, the signs of neglect would become harder to ignore. Water treatment plants would stop functioning, leading to contamination in rivers and reservoirs. Food in supermarkets and warehouses would begin to rot, feeding explosions in rodent and insect populations. Domesticated animals would be left to fend for themselves. Some would adapt, others would die out quickly without the structures we've built for them. The silence of human voices would be replaced by the sounds of other species expanding into spaces we once dominated. Over weeks and months, the natural reclamation would accelerate. Plants would begin to push through cracks in asphalt and concrete. Without maintenance, drains and gutters would clog, leading to flooding in low-lying areas. Wooden structures would start to decay, while steel would rust in the moisture of unventilated air. In some places, wildlife would return in dramatic numbers: wolves in suburban streets, bears in abandoned neighbourhoods, birds nesting in the empty frameworks of office towers. Years into our absence, entire urban landscapes would transform. Buildings with glass facades would collapse as weather and plant growth weakened their frames. Roads would fragment under the steady pressure of roots and seasonal temperature shifts. Bridges would fail without inspection and repair. The great landmarks of our time, the structures we assume will stand for ages, will be brought down by the same slow forces that erase mountains over geological time. Only here, the pace would be faster. Over decades, cities would dissolve into forests, wetlands and grasslands depending on climate and geography. Rivers would reclaim their floodplains. Coastal areas would shift as tides and storms reshape the shorelines. The remains of our industries, steel plants, oil refineries, chemical factories, would rust, leak, and eventually be buried under sediment or overgrown by vegetation. Our tallest towers would be unrecognizable heaps of debris. Some things, though, would last much longer. Plastics, unless exposed to sunlight, could persist for hundreds or thousands of years, breaking into smaller pieces but not fully decaying. Glass, ceramics, and certain alloys would endure for even longer, though scattered and degraded. The remains of underground infrastructure, tunnels, pipelines and foundations, might persist for hundreds of thousands of years in some form, shielded from erosion. Even on those longer timescales, most of what defines our present world would fade. The written word, stored on paper or in digital form, would vanish quickly without active preservation. Digital archives would be gone within decades as storage media decayed. Stone carvings might survive for millennia, but they too would eventually wear away. Without someone to maintain the meaning, even if fragments survived, they might be indecipherable. From a geological perspective, the most enduring legacy would likely be chemical. The carbon from our fossil fuel use would remain in altered isotope ratios in the rock record for millions of years. Layers containing plastics, fly ash from coal burning, and traces of synthetic compounds would form a distinct boundary that future geologists or future intelligences could detect. These would be the telltale markers of a technological civilization, even if all visible structures had vanished. If the planet kept turning without us for tens of millions of years, those markers would grow faint but not disappear entirely. In some ancient strata, there would be an anomalous layer, thin compared to the vast geological column but distinct. A sudden spike in carbon isotopes, the presence of long-lived synthetic molecules, microscopic fragments of industrial products. That might be all that remained of us, compressed into a band no thicker than a human hand. What's striking in this thought experiment is how quickly most of our physical presence would be erased. For all our concrete and steel, for all our sprawling cities and engineered landscapes, nature would reclaim the surface faster than we like to imagine. It would be the hidden, microscopic and chemical changes that endured. And that, in turn, shows how plausible it is that if there were civilizations before us, their surface traces could have been wiped away just as completely. Thinking about our absence also forces a question about what kind of mark we want to leave. Right now, we are actively choosing our future legacy, whether we intend to or not. The materials we use, the energy sources we depend on, the way we interact with ecosystems, these decisions will determine what is visible to anyone who studies the Earth long after we're gone. If the most durable evidence of our existence is environmental damage, then our story might be read very differently than we would tell it ourselves. And there's another angle. The absence of us would not mean the absence of intelligence forever. The Earth's history suggests that life rebounds from mass losses, often diversifying into new forms. In our absence, the ecological niches we occupy would open to other species, some of which might evolve higher intelligence over time. The cycle could begin again, just as we've been wondering it might have before. If so, those future minds might one day look back, if they could, at the faint marks we left and wonder who we were, just as we now wonder about those who might have come before. There's something quietly reassuring in knowing that not every question has an answer. We're taught to think of unanswered questions as problems to solve, gaps in our understanding to be filled. And in many cases that's true. We build science and history on the desire to close those gaps. But when it comes to the deep past, especially the parts of it that might involve other civilizations long gone, there's a certain peace in letting some questions remain open. It's not just about the romance of the unknown, though that's part of it. It's about recognizing that mystery has a role in shaping the way we see our place in the world. If we could map every corner of history, if we could account for every rise and fall, the past might feel like a closed book. There would be nothing left to discover, nothing left to imagine. And imagination, as much as data, is what keeps us curious. We already live in a world with mysteries in plain sight. There are ruins whose builders we know, but whose reasons remain debated. There are languages we've recovered in fragments, but whose full meaning escapes us. There are fossil species that stand at the edge of what we understand about evolution. These puzzles anchor us in the knowledge that the human story is complex and incomplete. Now extend that feeling beyond the human story, to a time when, if the idea is right, we weren't here at all, yet someone else might have been. That possibility invites a kind of humility. We are used to thinking of ourselves as the first and only ones to reach this level of complexity. To imagine that others might have done it long before us doesn't diminish what we've achieved. It simply puts it in a broader frame. We stop being the sole authors of civilization on Earth and become part of a much longer, older tradition, even if we only suspect it exists. That tradition is built on the rise of intelligence wherever conditions allow, on the experiments nature runs in shaping minds that can plan, create, and reshape their surroundings. And because we don't know if such predecessors existed, they remain free to be many things in our imagination. They could have been ocean dwellers with sprawling coral-like cities, or forest creatures who worked with living trees to shape their homes. They could have been small and quick, relying on intricate networks of communication rather than towering structures. They could have looked nothing like us at all. In their mystery, they can be as strange as we like because we are not bound by evidence, only by what is plausible within the boundaries of nature. This flexibility makes the idea useful too. It can act as a mental exercise, a way of testing our assumptions about civilization. What is essential for one to form? How much of what we think is necessary is really just a reflection of our own biology and culture? If another civilization could exist without fire, without wheels, without metallurgy, then maybe we're too narrow in our definitions. And if they could create beauty, stability, or knowledge without the kinds of environmental damage we produce, then perhaps there's something in that example, even imagined, that could guide us. The comfort also comes from knowing that some mysteries can survive the passage of time intact. In our world, there are events and patterns that resist explanation not because we haven't tried, but because the evidence is gone. That's the nature of deep time. Rock layers are erased, organic matter is recycled, tectonic plates carry whole continents under the crust. Over millions of years, the physical record becomes selective, preserving only a fraction of what once existed. If there was a civilization before us, the odds are stacked heavily against us finding proof. But that also means their story remains theirs, untouched by our interpretations. There's a certain generosity in that if you think about it. Not every past needs to be rewritten by those who come after. Some can remain whole in their own moment, unobserved but complete. When we imagine them, we're not reconstructing a truth so much as building a bridge between our present and an absence we can't fill. That act of imagining is its own reward. It sharpens our awareness of what it means to exist, to leave traces and to be forgotten. And yet, mystery doesn't mean isolation. Even without evidence, the idea of a past intelligence connects us to something larger than ourselves. It reminds us that we share the planet with a vast history of life, most of which is gone, but all of which contributed to the conditions we now live in. We are inheritors not just of genetic material, but of landscapes shaped by billions of years of interaction between life and the planet. In that sense, even a vanished civilization we can never prove might still be part of our lineage, if only in the way their existence or their absence shaped the path of evolution. Holding on to a mystery also allows room for wonder in a way that hard answers sometimes can't. It keeps us in the habit of asking, what if? And why not? It encourages exploration without the expectation that every journey will end with a discovery. That's an important mindset because the universe will never run out of questions, and we won't always have the tools or time to answer them all. Accepting that can make the unknown less frustrating and more like a companion, something that travels alongside us, shaping the way we think and see. In practical terms, mystery can even be protective. It stops us from assuming we've reached the limits of what's possible. If we believed firmly that we were the first and only, we might also believe that the end of our civilization would mean the end of intelligence on Earth forever. But if we allow for the possibility that others came before, and that others could come again, then our perspective shifts. We become less the sole stewards of a rare spark, and more one link in a chain that may stretch across eons. That doesn't mean our survival doesn't matter. It means our story fits into a bigger one. And maybe that's the real comfort. We can do our best, knowing that we're not starting from nothing, and that we're not the last word in the planet's history. Whether or not anyone ever proves a pre-human civilization existed, the possibility itself is enough to keep us looking deeper into the past and thinking harder about the future. It turns the absence of evidence into a kind of shared space between imagination and reality, a space where science and curiosity meet without rushing to close the gap. The mystery, in this sense, isn't just about them. It's about us. It's about how we choose to live knowing that we'll one day be part of someone else's unanswered questions. It's easy to get lost in the sweep of deep time, to spend so much energy imagining what might have been or what might come next, that the present becomes almost an afterthought. But if you pull back from the timelines and return to the moment we're actually in, you find something worth holding on to. This is the one point in history we can experience directly. The only era where we don't have to guess, where we're not relying on fragments and interpretations. It's the one part of the story we get to live from the inside. Right now, we are the inheritors of every twist in the planet's history so far. We're standing on ground shaped by billions of years of geology, under a sky with an atmosphere adjusted by countless generations of life before us. The arrangement of continents, the chemistry of the oceans, the balance of gases in the air, none of it is accidental. It's the product of everything that came before, including the extinctions, the recoveries, and the quiet stretches in between. This present moment is not a blank slate. It's dense with momentum from the past and potential for the future. In it, we carry the knowledge and tools to understand far more about the world than any species before us. We can look back into the deep past with satellites, microscopes, and chemical analysis. We can model possible futures with equations and computer simulations. We can see ourselves from orbit and recognize the changes we've made to the planet's surface in just a few centuries. That awareness is rare in Earth's history, and may be rare in the history of any planet. Being here now also means having choices. Our impact on the Earth is immense and accelerating. That's a reality we can't escape. But the way we use that influence isn't predetermined. We can choose to amplify the damage we do, or we can choose to limit it. We can decide whether our legacy will be a sharp break in the geological record, or a more subtle presence that leaves room for what comes after. The past might be fixed, but the future is still open to the decisions we make right here. It's worth remembering that those decisions don't have to be grand gestures to matter. History is shaped by accumulation, the slow build of habits, systems, and ideas. A civilization isn't just its monuments or its leaders, it's the sum of countless individual actions repeated day after day. Those actions are happening right now, in everything from how we use resources to how we pass on knowledge. In that sense, the present is the active layer where the past and future meet, and what we do in it decides which patterns will persist and which will change. If you think of our time as part of a larger cycle, then this moment is a critical phase. We are far enough along in our development to have altered the planet in visible, measurable ways. That puts us at a point where the same pressures that may have challenged any earlier civilization, environmental limits, energy demands, internal complexity, are building around us. We can study our own trajectory in real time, seeing the warning signs and the opportunities. If there is a way to extend the lifespan of a technological civilization beyond whatever natural limit the cycle imposes, this is when we'd have to find it. And if we are the first civilization, not part of any cycle, then our choices matter even more. We might be setting the precedent for what an intelligent species can do with a planet. That's an enormous responsibility, whether we ask for it or not. In that version of history, the patterns we establish now could echo into whatever comes next, millions of years from now, if intelligence rises again. We could be the example that future minds remember, or the cautionary tale they study. Right now is also the only place where the questions about the past and future intersect. When we speculate about earlier civilizations, we are really testing the boundaries of what's possible. Could intelligence evolve more than once? Could technology rise and fall without leaving obvious traces? Those questions are about them, but they are also about us. They ask whether we are part of something larger or entirely on our own, whether our challenges are unique or shared, and by living in the present, we have the advantage of being able to act on those questions even without definitive answers. The present is where we can build records meant to last, not because we expect them to, but because we know how fragile evidence can be. It's where we can decide what knowledge is worth preserving and how best to preserve it. If the geological record is the only sure way to communicate across millions of years, we can shape that message intentionally, rather than leaving it as an accidental byproduct of our industrial footprint. That's a rare kind of agency in the life of a species, and one that's easy to overlook when we're focused only on the immediate. Where we are right now is also a moment of incredible connection. We can communicate across the planet in seconds, share ideas instantly, and coordinate efforts at a scale no earlier society could have imagined. That network is fragile, dependent on infrastructure that would vanish without maintenance. But while it exists, It's a tool for shaping our collective story. It means that the decisions we make today aren't isolated. They ripple outward faster and farther than at any other time in history. And yet, despite all this reach and knowledge, the present is still full of limits. We can't see every consequence of our actions. We can't predict every shift in climate, every political change, every innovation or setback. We live in a blend of control and uncertainty, just like every civilization before us. The difference is that we're aware of it, watching ourselves from within and from a distance at the same time. That perspective is a strength if we use it well, and a distraction if we get lost in it. Living here, in this exact moment, means holding two truths at once, that we are temporary and that we have influence. Temporary because no species lasts forever, and influence because while we are here, we can alter the course of things. It's a combination that can lead to carelessness or to carefulness, depending on how we choose to see it. The deep past suggests that if we don't pay attention to that balance, the planet will eventually reset without us. But it also suggests that life is resilient, that recovery and renewal are part of its nature. Where we are right now is a crossroads we can only fully recognize in hindsight. Future generations, whether human or something else, will see the shape of our choices more clearly than we can. They'll know whether we extended our time in the cycle or cut it short. They'll know whether we left behind a legacy of learning or of loss. For us, it's harder to see because we're in the middle of the story. But that's the nature of the present. It's always in motion, always becoming the past. And that's why, even while we imagine what might have come before and what could come after, it's worth pausing to notice where we stand now. The moment itself is fleeting, but it's also where every decision is made, every action taken, every small shift in the course of history set into motion. It's the point of connection between the Earth's long memory and the possibilities still ahead. Thank you for letting your thoughts wander here with me tonight. If the journey left you curious, or gave you something steady to drift off to, I'd be glad if you stayed for the next one. There's always more to explore, more quiet questions to ask, and more ways to see the world differently. Until then, rest well, and let the story keep going in your own dreams.